Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to use the PLC S7-200 Smart CPU SR20, send data to PLC S7-200 Smart CPU 20 also by using the Modbus RTU for communication. Okay, so before go to create the program blocks or use the library, I would like to explain the concept a little bit. Okay, so here is the PLC S7-200 Smart that we will set the IP address with 192.168.2.1. So this IP just example. So if we use the step 7 microwave smart connect to the PLC, we can change the IP address to be made with the computer IP address. Yeah. So if we choose the computer IP address rank like this, so we can set the manual of IP address of PLC followed by your computer. Okay, and here is the Modbus cable. Actually this is a Profibus cable, so we can connect from port 0 of PLC 1, example CPU 1, and here is the CPU 2 that pin number 3 is connect with pin number 3, pin number 8 connect with pin number 8, and pin number 3 is plus data, pin number 8 is minus. Okay, so this is a CPU master and this is a CPU slave. So I will create the program and then test step by step. And here is the software that we will use. The first one is step 7 microwave smart. The second one is Vinci Flexible Smart version 3, and I will use the HMI model 700 IE V3 also to connect with the switch, and then from the switch number port number 1 I will connect to the PLC 2, port number 3 I will connect to PLC 1. So all these ports we can use for communication, yes, with the HMI, and I will set the IP address of PLC 1, PLC 2 and HMI, and also computer follow this step. Okay, so if we set IP address like this, we can ping from the computer to the PLC 1, from computer to PLC 2, from computer to the HMI, yes, and then we can create the program from here, from the PC, and then download to the PLC, and we can also design the screen HMI project and then download to the HMI also. Okay, so this is just concept of the Modbus RTU connection that we will test step by step. So let everyone follow me step by step. Yes, let's go. Okay, so first we need to use this one. Yes, but before use this one, I would like to back to the slide for explain of the Modbus. Yes. Okay, so let's continue with two slides. Here is the basic of the Modbus RTU, and here is the address of Modbus, yes, that we will use. Follow this step, yes. So if we push F1, we open the step 7 microwin smart and we type Modbus, we will see this manual operation Modbus. So we can read and follow this step, yes. And then go to the next slide. Here is the address of the Modbus also, yes. So we can read. And for part 1, I will send the data from CPU 1 to CPU 2 via IB0 to QB0. After that, I will send the data from CPU 2 to CPU 1 with the IB0 to QB0. Okay, so totally 8 bits sent from CPU 1 to CPU 2 and then 8 bits from CPU 2 to CPU 1. Okay, and here is the parameters, yes, that we will learn together. So first we can go to the Modbus library. If we install the step 7 microwin smart software, we will got the library of this Modbus. Okay, so I would like to explain the blocks. Yeah, the first one is enable, yeah, block. We can use always on SM0.0, and this is the mode. It means that if we turn on, we enable the mode of Modbus. Let's see here. On it means that enable Modbus mode. Off it means that use the PPI module. Okay. Okay, so let's go to baud rate. It means that transmission rate. Normally we will use the 9600, and here is the priority. So when we set 0, it means that no priority. We choose 1, it means that OGD priority. We use 2, it means that even. Yes, so we will use 2. And here is the port 0, it means that RS485 integrated in CPU. When we choose 1, it means that RS485 or RS232 located on the optional CM01 signal board. Okay, and here is the timeout. Actually, normally we use 1000. It means that 1000 millisecond and equal 1 second, right? And here is the done. Done, it means that when the block is true, it means that it will done. And here is the error. We have a lot of error. 0, it means that no error occurs. 1, it means that invalid priority type. And then we have many errors that we can check if the status show. Yes. So let's go to next step. I will explain first before we create the program. Otherwise we don't understand and then we cannot do it. Okay, and then we will go to the Modbus message. So the first one is EN, it means that enable. Yeah, and first let's use the clock memory SM0.6. It means that 1 second on, 1 second off. Okay. And for the slave, it means that the parameter slave is the address of the Modbus slave device. Okay, A it means that we use the Modbus slave address number H. And 1 it means that read write, so we can write the value. Yeah, we choose 1. And address here, so it is the address of Modbus address here. It will start from 01 to 9999. Yes, for output coins. So we will choose 1 because we will send 2 output, right? Okay. And for another type, we can see here, follow this step. For count, it means that the parameter that assign the number of data elements to read or write in this request. Okay, let's see here. So we need to follow this step. After that, we will go to the library memory location. Yes. So memory location is very important that we can set, because when we use the block Modbus, we must assign the address to be ready. Yes. So I will assign VB5000. Yes. And this is a step for assign the memory. The first one, let's go to file. Second, let's click memory. And then third, we can fill here with VB5000 and then click OK. Okay. And then after that, we will download the program to the CPU1. Yes, finish for CPU master. And the next step, we will go to the CPU slave. It means that CPU2. So first, we can drag and drop the library of the Modbus block to here. And we will fill the address. Yeah. Follow this one. And we will insert the Modbus slave. Yes. And then we assign the memory allocation also with VB5000. And then we will download the program to the PLC2. Okay. So this is step 1 that we will follow this slide. Yes. So let's go. Okay, so first let's go to open step 7 microwin smart. Right now I will use version 2.5. Yes, that I already installed in my PC. And if we already install in our PC, we will got the library. Yes, many library for this Modbus. Yeah, we can use Modbus RTU, Modbus RTU master, RTU slave, TCP IP, yeah, TCP server. Yes. And then we can use many function, yeah, for this library. So version 2.5 is many library that we can use. So let's go to our concept. So let's go to the slide. I already convert to PDF. So the first one I already explained. Yeah. So we will send the IB0 to QB0 of PLC2, right? So let's go to this step. The first one, we need to insert the Modbus control, right? So let's go to Library tab, and then let's go to Modbus Master, right here, and then drag and drop the block to the main program. Okay, we will go like this. So the first one here should be enabled, right? Okay, I will zoom. So the first one we can enable with SM0.0. It means that always on. Yes. And for mode we can use the always on also, right? Follow this step because we need to enable the mode of RTU, right? So we can go to SM0.0. Yes, or enable the mode, and we can use the baud rate, right? So baud rate actually we use 9600, and priority we will use 2, right? Here we will use 2. It means that even. Yes, so I will put 2. And for the part, right, here is the part, so we can follow here. Part I will use 0. It means that RS485 integrated in the CPU. Yes, so I will use 0. And for the time, it means that time out, right? So I will use 1000. It means that 1 second. So 1000 millisecond, right? And for the done and error, we can use another memory, example M0.0, MB1, yes, example like this. And we need to insert for Modbus message, right? So let's go to Modbus message. Okay. And the first one here, we can enable also, right? So we can follow here, enable. If the block is done, so we can enable the block Modbus message, right? Okay. So I will use NO and then copy from here. Yeah. Copy from the done. Yes. If this block done, it means that finish for initial, and then we will go to block number 2, right, for Modbus message. And first it means that first initial, so we can use the clock memory. Example, we can use SM0.6. It means that the clock scan, right? So we can press F1 and then SM memory, special memory, right? So SM memory, we can read many SM memory that we can use. Okay, let me find the SM0.6, right? SM0.6, it means that clock scan, right? Okay, so we can use clock scan to scan the block. Yes, so I will use SM0.6 and then PAL because we need only first, right? So this one we can use positive edge, yes. And for the slave, it means that slave address. So example H, and here is the read write. If we put 0, it means that we cannot write. So right now we put 1 because we write the memory to the CPU slave, right? And here is the address. I can use 1. For count it means that the assign the number of data element, right? Okay, so we can count each bit. Example, if everyone would like to send two bytes, 16 bits, right? So we can enter with 16 bit. So right now I will use only 8, right? So I put 8, 1 byte, right? And here is the data. So data will start from IB0, yes. And for that I will use M0.1, MB2, yes. Sorry, MB2, yes. So this is the data that we will send to the slave, right? So we will insert one more for send or got the data from CPU slave, right? So we will insert one more block for Modbus message. Here we can enable, yes, we can enable, follow my slide. So this one I will use as M0.0 also, yes. So M0.0, it means that the block number 1 is finished here. And then block number 2 will turn on, right? So I will use N, it means that negative H. Okay, so I will use this one, yes. SM0.6 also, right? It means that the clock memory scan, yes. So I will use NO and then SM0.6, and I will use negative H. And here is the slave H also, right? And read write, it means that we got the data from the CPU slave. So we no need to read, no need to write, right? We need only read, so I will put 0. And here is the address. Let's see here. The address is 10,000, right? 10,001, yes. So I will put address 10,001 and count. We will got 8 bits also, yes. And the data is should be 0, right? And this one we can put M0.2, MB3, yes. So that's all for create the block. But when we compile the block, we will got error, right? Let me test. So I will compile, and we will got the error is 135 error, right? 135 error, because we not yet put the memory allocation to this block, yes. So first let me go to setting the CPU, yes. Example, the CPU SR20, I will go to communication and then I will set the IP address, right? And for the CPU one, we can follow with this step. Yes, 192.168.1.2.1, right? .2.1 first, and then go to stand up. I will start run the CPU, and then I will assign the memory allocate to the block, right? Otherwise we will got error. Yes, many error. So let's go to file and then go to memory. Yeah, here click, and then I will put VB 5000. Yeah, example VB 5000, and then click OK, and then let's compile again. We will got error 0. Okay, so good. And then we will save the CPU 1 or CPU master. Yes, so this one Modbus Rtu S7-200 Smart project, and this one for CPU 1 or master, right? So master. Okay, for RTU master block we already created, right? And then we can command a little bit here. Example, initialization session of Modbus. Okay, and this one send IB0 in that 1 byte, right? One byte I0.0 to I0.7, right? To PLC 2 or slave, right? Okay, and this one should be got QB0 to QB0.7, right? 0.0 to QB0.7 from PLC 2. Yes, then we can save, and then we will go to create the block for CPU slave, right? Okay, let me minimize, and then open one more step 7 microwin smart. Yes, and we will create the same procedure that I already showed in the slide, right? For CPU 2. Yes, here. So we will use the Modbus initial, yeah, for slave. This one I will minimize and then go to slave. So for initial, initialization of Modbus block, and then we will go to library and then go to Modbus Rtu slave, right? Okay, click here, and then we will use this block, drag and drop. Okay, so first is enable, right? But enable we will use only one scan for enable, right? So SM0.1. Okay, SM0.1, it means that first scan when we turn on the power of PLC or we start the CPU, it will first scan on, yes, and then off, on only one scan, right? And for the mode, we can use another mode, example mode 1, yes, we will use mode 1, address 8, right, and the baud rate the same, priority 2 also, port 0, delay 0, 8 0 AI 0 and VB 0, right? Okay, so we can follow my slide. Mode 1, address 8, baud rate 9600, priority 2, port 0, delay 0, mark IQH, mark AI 0, and this one 0, right? And the whole link register will start from VB 0, and for done we can use M0.0, MB1, yes, and then we will use one more for Modbus slave, right? Okay, so Modbus slave, example M0.1, MB2, yes, and don't forget put the SM here, should be this one, right? SM0.0, it means that enable, right? So we can enable with SM0.0, and then if we compile like this, we will got error also, yeah, error 74, yes, because we not yet put the memory allocation, right? So let's go to file and then go to memory, and we can put VB 5000, yes, and then we can compile again. We will got error 0, right? Okay, then we can save, and this one should be CPU 2 and slave, right? Okay, and go to the CPU property communication, set the IP address with 192.168.2.2, right? Okay, and then we will go like this. Okay, I will open like this. then zoom out a little bit. Okay, one more. We can do like this. Okay, I will zoom out a little bit. Okay, so this is CPU 1, it means that master. Here is the CPU 2, it means that slave. So we will download one by one to the CPU, right? So before download, we can go to set the IP address of our computer to be the same rank of the CPU, right? For CPU 1 is 192.168.2.1. CPU 2 is 192.168.2.2. So I will set my computer IP address with 192.168.2.253, yes, and subnet mask 255.255.255.0, yes. Okay, and then we can ping for test. Go to command prompt, so cmd, we can run as administrator. Then we can use cmd ping 192.168.0.2.1. Yes, can ping for CPU number 1, and one more. So ping 192.168.2.2. yes, we can ping also. So we can connect, right? So we will download the master program to CPU number 1 and slave program of Modbus to CPU number 2. Okay, so I will go to communication and then choose the network that I already connect to the switch. Yes. Okay, then we will detect two CPUs of PLC, right? The first one is CPU number 1. I will choose this IP. Actually, we can click plus line and then we can see the CPU is blink. Yes. Okay, we can stop and then we can choose for download. Then download button, and then I will download the program to master CPU. Okay, and then we can online and start the CPU. Yes. Okay, so I will start the CPU number 1. Yes. Finish. And then we will download the program to CPU number 2, right? So let's go to communication and then choose the network driver. Yes. And then I will choose the CPU number 2, right? 192.168.2.2. We can click here to plus the LED. Yes. And then we can click OK. And then download to the CPU. Finish. And then we will start the CPU 2. Yes. So if we start the CPU 2, let's see the condition. Here is 1, rest. It means that done. So if I stop the CPU, yeah, let me stop the CPU. Okay, stop the CPU. Start the CPU again. Yes. So we can test the data. Yes. So first we can go to the status chart, right? I will choose the data. So this one should be IB0, right? And this one should be QB0, got data from the CPU slave, right? So I will use binary. Yes. And then here for CPU slave, I will use status chart also. Yes. And here should be QB0, right? And this one should be IB0. I will use with the binary also. Yeah, you ask binary. So we can online. Yes. And we can online here also. And I will force the signal from here. Example, I will force with the 8 bit on with 8 bits, right? So basically we can use calculator. Yeah, if we would like to turn on 8 bit, we can use binary, right? Click binary and then we can use 8 bit. Yes, 8 bit. So convert to decimal, we will assign with decimal 255, right? So I will force 255 here and then click here for force the signal. Yeah. When I force the signal, let's see QB0 is turned on all and the output is turned on also. Yeah, let me show. Okay, let's see the output of PLC slave is turned on. Yes, 8 bit, and this is the CPU master. Yeah, that connect with the cable. Yes, here. So it worked properly from CPU master to CPU slave. Yes. And if we would like to force the signal from CPU slave to CPU master, we can write like 255 also and then force the signal. Yes, it will turn on 8 bit also. Yes, let me show. Yes, let's see the CPU master is turned on 8 bit also for output. Yes, so it work. So the communication between CPU master and CPU slave is work perfectly. So I will write 0, it means that 420 turn off, and then here unforce. Yeah, and this one I will force to 0 also. Yes, and then unforce. Yeah. So we can also create the HMI for start send the data from here to here also. Yes. So let's create this is just example, so we can create send data from PLC 1 slave, right? Sorry, master to PLC 2 slave. Yes. So if we would like to control via HMI, we can follow like this. Yes. So example, I will use M0.0, right? We already use, right? M0.0. So example, I will use M 1.0. Yes. And then let's turn on the output, right? Turn on the output. And we also use the push button for test also, right? Okay, let's test together. So here I already put and connected the cable to the push button. So if I enable the PLC example, the bit number 0, yes, let's see the PLC slave is turned on also if I enable the input of PLC master. Yes. And for bit number 2, yeah, I will push the button. Yes, on, and then see here is on also. Yes. And this one on, and here is turn on. Yes, I will hold the signal from the input, and let's see the output. Here is turn on. Yeah, I will release, and then let's see is release. I will turn on one more input. Yeah, and let's see the output of master is turned on also. Yes, so it worked perfectly. And if everyone would like to show the status of the output on the HMI, we can also create the HMI. So let's open the WinCC Flexible Smart version 3, and then create the new project here. Right now I will use Smart IE 700 IE V3 here to be the same with my hardware. Yes. And then we will create the communication by link to the PLC 1 and PLC 2, right? So example, I will create the connection for master CPU, and I will connect to the schematic S7-200 Smart, and I will use the IP address of Ethernet, yeah, because we link via LAN cable, right? So 192.168.0.2.253, right? It is the IP address of my PC. And for this one, 192.168.2.1, right? PLC 1. And for PLC 2, we can also use slave, right? This one should be slave. And connect with the PLC smart also. And this one is the same, but this one should be changed to 2. Yes. So we need to show the status of output of PLC 1, right? So we will create the text. So for CPU 1, this one should be Q0, okay, PLC 1, or we can write master Q0.0. Yes, it is Boolean, right? So I will choose Boolean, and then it will start from Q0.0. This one should be bit 1, right? Master CPU bit 1. This one should be 0.1, right? Q0.1 master CPU bit 2, and we can choose like this. Yes. Okay. So one more, right? 0.7, because totally 8 bits, right? So from Q0.0 to Q0.7, right? And this one we can try with the master bit 3, master bit 4, master bit 5, master bit 6, master bit 7, and master bit 8, right? Okay. And we will show the status of CPU slave also, right? So we can start from slave Q0.0, and this one I will choose the connection for slave CPU, right? It's very important here. If we choose the wrong connection, we cannot control to another PLC, or we cannot see the status from the PLC, right? So I will choose slave, and then it will start from Q0.0, yeah, and this one should be slave CPU bit 1, right? Then I can drag and drop like this. Okay, delete 1. Okay, then I will got from Q0.0 to Q0.7 of PLC slave, right? Okay, so this one should be copy and then paste here, Q2, case here also 3, 4, 5, bit 6, bit 7, and bit 8, right? Okay, and then we can save the project. Okay, I will save to mode bus, right? Okay, so mode bus HMI, yes. And then I will go to separate the screen, yeah, the same as the previous video. So I will separate the screen like this. The right side is for PLC 2 and the left side is for PLC 1, right? Okay, so I can go to property and then change this one to be bigger than before, right? And for the background I will change to this color, yes. And this one I will use green color for separate, yes. And then I will use the text. Okay, the text I will use the PLC 1 or PLC master, PLC master output status, yes. And I will use the text, I will use yellow color, and then I will use bold, and then I will increase the size to be maybe 17, yes, like this. And for this one should be a status of PLC slave, right? So I will rename this one to be slave, yes. Okay, and then we will show the status of the 8-bit of PLC master, right? So let's go to create like this. So bit 1, example bit 1, bit 2, bit 3, bit 4, and then we can make us like this. Okay, and then I will copy 4 more, yes. And then I can change color to be red color when status off, and then green color when status on, right? So I can copy for slave also. Okay, like this. Okay, like this. And for this one we can write example bit 1, bit 1 until bit 8, right? So bit 1, bit 2, bit 3, bit 4, bit 5, bit 6, bit 7, bit 8, right? So I will rename this one to be bit 2, bit 3, bit 4, bit 5, bit 6, bit 7, and the last one for bit 8 for CPU master. So I will copy to be the same as the CPU slave, right? Okay, good. Like this. I can save again. And then we need to show the status, right? So here example show the green, it means that turn on. Yes. So let's go to property and then go to animation and choose master status Q0.0 until Q0.7, right? So I will choose master Q0.0 and then change the color. When status 1, it means that it turn on. I will change to green. Yes. This one also master Q0.1. I will use bit, and then when 1, I will change to green. This one also Q0, sorry, master Q0.2 1, and then change to green. Master Q0.3 1, and then change to green. Master Q0.4, when it 1 status on, I will change to green. Master dot 5, right? When 1, I will change to green also. Master dot 6, right? When 1, I will change to 1 green. This one master 0.7, right? The last one. So we can 1 and then change to green. Okay. And then for the PLC 2, yes, PLC slave, we can also use the slave Q0.0. When 1, I will change to green. Yes. And for this one, we can go to slave Q0.1. We can do the same. Yes. This one slave Q0.2, right? Change to green. This one should be slave Q0.3, right? Okay, so we can for bit here, this one Q0.3 and this one Q0.4, right? So slave Q0.4, when status 1, I will change to green. This one slave Q0.5, change to green. slave Q0.6. I will change to green also. When the status on, yes. The last one Q0.7. One I will change to green. Okay. So that's all, and then we can save, and then we can simulation. Yes, can simulation before download to the real HMI. Okay, and then we can go online with this PLC. Yes, and then go here. So no bit on, right? So if I will for the signal, yeah, example I force 8 bit, so 255 force, yes. Let's see, 8 bits is turned on, right? So this one why not turn on, not green? Let me check again for Q0.3. okay, this one, right? Go to property again. Oh, this one should be changed to green, right? Okay, right. And then we can save and then simulation again. Okay, so it green. So simulation is green, and then we can force 0. Okay, and then we can unforce all. And for PLC slave, we can also test. So I will choose 255 8 bits, right? Force. Sorry, should be force here, right? Cancel all force, and then I will force here. 255 force. Let's see, the status of PLC master is turned on also. Okay, so I will remove force. Yes, and we need to download the project to the real HMI, right? So but before download the project to the HMI, I would like to explain about how to setting, because here is the HMI Smart 700 IEV3. We communication by using the LAN cable for download, right? So first, let's go to set up the IP address on HMI first. Follow my slide. Yes. So let's go. So first, let's go to transfer tab, and then we need to enable all these options, right? And then press OK, and go to the Ethernet. Yes, and we need to set the IP address of the Ethernet, because we use the LAN cable for communication between our PC to download the project to this HMI, right? So let's go to specific IP address. So I will put 192.168.2 example.3. Yes, and subname is 255.255.255.0, and then click OK. Yes, and then click transfer. Yes, and then let's go to our PC to transfer the data to this HMI. Yes, because we already created, right? So first, let's choose the command prompt, ping the IP address that we already setting on HMI, right? And we already connect the LAN cable from my PC to the switch and from the switch to the HMI. So we can test with CMD and then ping 192.168.2.3. It's so like this, it means that the communication cannot communication between our PC to the PLC, right? So let me check the LAN cable again. And then we can ping again. Yes. Okay. So right now we can connect from our PC to the PLC and HMI, right? So we can download by press this button and then fill the IP address here. Yes. So the IP address of my HMI is 192.168.2.3, right? And then please download. Yes. Yes to download to confirm. Right now it finished downloading, right? So we can online. Okay. And then we can test it, right? By push button. So if I push the button here, yes, let's see the HMI of PLC slave is show, yeah, for bit number 2, yes, and the PLC is show bit number 2 also. If I release the button, it will not show also, yeah. So if I push the button number 1, yes, button number 1, the input of PLC master is turned on, and then the output of PLC slave is turned on, and the HMI is show green also, yes. So if I test the input of PLC slave, if I turn on the input, let's see the output of PLC master is turned on, and then let's see here the lamp is turned on. Yes, I will enable one more. Yes, turn on also. Yes. So if we force the signal, yeah, let me force the signal from the computer, and then let's see the status again. Yes. So I will go to start 1 and then for the signal to be 255. Yes, turn on, and then For PLC slave, I will force also. I will force 255 and it will turn on all. And let me show the status on the HMI. It will green on, right? Yes, let's see here, it green all. And the PLC is green also. Yes, PLC is turned on all for output for both PLC slave and PLC master. Okay. Okay, it turned on all. So this is a part 1 about how to communication and link the data from PLC S7-200 Smart to S7-200 Smart by using the Modbus RTU for communication. Okay. And in the next video, I will show the part 2 about how to link data from the PLC S7-200 Smart to PLC S7-200 Smart also by using the analog signal. Okay. And I will go to use the HMI also on the next step, next session for part 2, and then link to the PLC by using this HMI. Okay. So thank you very much for watching my video. And if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today we will continue to part 2 about how to link data from PLC S7-200 Smart CPU SR20 to PLC S7-200 Smart CPU SR20 by using the Modbus RTU. In this section, we will send the VW100. It is just example. We send to the CPU slave by VW200, and I will send the VW202 from slave CPU to the master CPU by using the address VW102. Okay, let's go to previous video. Yes, in the previous video we already learned about how to send the data for 2 bytes from the PLC S7-200 Smart CPU SR20. This one, it means that send from PLC master to PLC slave, and we already tested with the HMI, for show the status of each bit. So today we will continue. Okay, let's go to slide. Okay, today we will send VW100 to VW200 of PLC slave, right? So this is the logic that we will create. So first we need to create more for Modbus message. Yes, here is the existing video, and we need to add one more for write the data and one more block for read the data. Okay, write means that write from the CPU master to CPU slave, and read it means that read the data from CPU slave to CPU master. Okay, and here is the data test that we will test with the HMI also. Yeah. So first let's go to the program, yes, software, to create more for Modbus message. Okay, so let's go with me together. Okay, so here is the previous project that we already learned in the previous video. So for CPU1, CPU master, yes, I will outline first. And then we need to create more for Modbus message, right? So I will delete this one first. So basically we can we can write command send data from PLC master to PLC slave or CPU1 to CPU2 by using the address VW 100 to VW 200, right? Okay, the slide. Let's see the slide again here. We will send one VW 100 to VW 200, right? So let's go to insert the library. Yes, we have library for this Modbus. So first, let's go to insert the library of master, right? So let me drag and drop the Modbus message from this library to the block. Yes. And here is the library, yes, that we can use. Okay, I will zoom in a little bit, easy to understand. Yes. So here is the enable, right? For enable we can use this one, so I can copy and paste. And for the first, it means that the first initial, right? So for this one we can use the reset, right? I will insert the new network for reset. So if I turn on the power, I will reset the M0.0. Yes. So every time that I turn on turn off and turn on the power of PLC, I will reset this one to 0, right? So I will use SM0.0 and then reset M0.0. Yes. So during I turn off the power, yes, and turn on again, M0.0 will reset to 0. Okay, it means that fall, and then it will turn on the connection again. Yes. And for this one, I can use M0.0. Yes. So this one, it will work after this one, right? So I will use M0.0. and I will use the P, it means that positive edge, and for this one it will turn on after this one on, right? So I will use NO and will use M0.2 and positive edge also. And for the slave address, I will use edge also, yes. And read write, we would like to write the data, right? VW100. So I will put 1 for write the data. And for the address, yes, for the address, we can follow this one, yes. For the address, we can start from for 3001, yes. So I will put 40001, right? Okay, this one, and then count 1, right? Count 1, and data is VB, right? VB100, yes, VB100. And for this one we can use the M0.3. Let me check again. This one should be M0.0. M0.0 here, M0.1 here, and this one should be M0.2, and create one more, right? So drag and drop one more for mistake. This one should be MB4, and this one I will enable by M0.0 also. And for this one first, we can use M0.3, right? And I will send this one also, yes. And for the slave is edge also, right? The address, and read write is 0 because we read only, yes, from the PLC slave, right? And for the address, we can use this address, yeah. For 0002, right? So 40002. And for count, it's only 1, right? Only 1, so we can put 1. And for the data, read from the CPU slave, we can use VB102, right? Okay, VB102, yes. And for this one, we can use M0.4, right? This one, I will put MB5. So let me check again. This one should be M0.5, right? So M0.2. This one M0. M0.1, yes. 0.0, 0.1, 0.1, 0.3, Yes, so that's correct, and then we can download. Yes, and for this one we can if this one complete, we can copy M0.4 to reset this one, right? So this one should be M0.4. Yes, so we can command here, read data from PLC slave VW 102, right? Okay, VW 102, and let's save the program and then compile. Okay, error 0, it means that compile successfully, and we can download. Yes, okay, and then we can online. Yes, so let's check here, no error occur, right? M0.0 is 1, right? Let me check. It should be not error, right? If we write like this. So this one always on. Yes. And this one M0.0. So M0.1 on. M0.4, and then M0.4 is turned on. M0.5, right? And for the CPU slave, we need to revise also. Yes, because the address is add more, right? So for CPU slave, I will revise this text, this address. Yes, because we send VW, right? VW 100 to VW 200, right? So I will put VW 200, so VB 200, and then I will save the project and then download, and then we can online. Yes, so let's see here, it is error, right? Yes, it is error. So let me check again. This one should be M0.0, M0.0. M0.0 turn on is turn on, and then M0.1, right? M0.1, M0.2, M0.2, M0.3, M0.3, M0.4, right? So it is okay, but it looks like communication is error, right? Communication error. Okay, so this one should be first scan only, right? So I will revise the logic to be SM0.0, yes, sorry, SM0.1 first scan, right? And then save and download to the CPU again and start the CPU. And let's check here. Now it's no error occur, right? The communication is working. Let's see M0.4 is on and off, on and off. It means that loop communication here, yes. So we can test. So I will minimize like this. So if no error occur, let's see here. It is 1, it means that done. Yeah, it done. And error 0, right? So it means that the communication is working properly, and we can test by send the data, right? So let's go to status chart and then status chart 1, and we will write the VW100, right? VW100 write to VW200 of CPU slave, right? Okay. And CPU slave will write VW202 to VW102, right? Okay, I will show as unsigned decimal, sorry, unsigned. And then we can test the signal by online here. Okay, I will online. And then we can test the VW100. So we can write example 1, 2, 3, yes. And then for the signal, $102. Then this one I will send example 600. So we need to revise this one a little bit more, yes. So I will offline, yes, because we need to use the more memory, right? So basically we can use like this, follow this step 1 to 8 for this one, 32 and 2, yes. So 1 to 8, 32 and 8, yes. And we can save and then download to the CPU again. And then we can online to test. Okay, let's see the data that we write from CPU A to CPU B is working. So example, I will change to 7, 1, 2, 5, 4, yes. Sorry, the big value, right? I will write only this. Let's see, the data is changed. And if we would like to write from here, example 1, 2, 3, 4, 5. Okay, the CPU master will change also. Okay, so we can use the touch panel here to write and read the data from the CPU master to CPU slave. Yes, so we can go to our HMI. Yes, and then create the new text, right? So for the CPU 1 or CPU master, we will use the VW100, right? So address VW100, it is the integer. Yeah, example, I will write integer. So VW100, yes, and we will got the data with VW102, right, from the CPU slave. Yes, and for the CPU slave, I will use the CPU slave selection, and then this one should be VW200, right? So the address will start from VW200, and this one is 202. Yes, and then we can go to the screen, and then we can create the text. Okay, create like this. I will change the color to be text color like this, and for the background I will change to black, and for the text size I will use this one. Yes, so we can use the format sample like this, and I will align the text to be center, middle. Yes, and for this one we can use D and can select with the white color. Yes, to be like this. Okay, so we can increase for the size. Yes, and we can copy for receive the data from CPU slave, right? So for the address here we can copy from here, and this one should be VW100, right? And this one should be VW102. I will increase the size a little bit. Okay, and then we can copy to CPU slave. Yes, and just change this one to be VW200, right? So I will change to VW200, and this one should be VW202. Yes, and choose the text. For this one is input, right? Yes, this one for input. So let me simulation. Okay, for if we choose input, we can write any number that we want, right? Okay, and for this one I will choose output. Yes, output we cannot write, right? This one I will choose input also, and for this one I will choose output. Yes. So for this address is the VW 100, right? And for this one is VW 102. So VW 102, and for this one VW 200, right? So VW 200, and this one VW 202. Okay, so we can save the project and then simulation, right? Okay, first we can simulation. So I will write this one to be okay. We will remove false first, right? I will remove the false signal here. Yes, cancel all false. Okay, and then we can write any number that we want. Example, I write 4 1 2 3. Yes, let's see. For CPU slave is changed also, and for this one I will write 1 4 7 8. Yes, this one change also. Okay, so it means that the data communication is work perfectly from the CPU master to the CPU slave. Okay, so I will download this HMI to the real HMI and then test together. Yes, so first we can go to the project of WinCC and I will ping to 192.168.2.3, right? The HMI that we already learned in the previous video. So we can click download and then choose the download button. Choose yes. Okay, finish. So let's go to the real HMI together to set the any number that we want, and we can simulation this one also. Yes, I will put here. Okay, so right now the PLC is turned on. Yes, and it select to run mode. Yes, so if we still use this one, we can also select yes for the previous video. Yes, this one also we can select. When select this one, it turn on. Yes, and we can also use the analog. Yes, right now I will set point the analog from here. Example 8886 from CPU A, right? CPU master, and then let's check the CPU slave is check also. And if I set any number from here, yes, from CPU slave, and then let's check the CPU master is changed also. Okay, so we can send the data, any data from the CPU master to CPU slave, right? Okay, so it working perfectly from the communication of CPU A and CPU master. Okay. So this is just concept how to link data from CPU A or CPU master or PLC S7-200 Smart by using the Modbus RTU. Okay. So I hope everyone will understand about my point, and the benefit of this project. So we can use only uh, profit bus or cable communication from the CPU 1 to CPU 2, so we can link another data that we want. Okay. So thank you very much for watching my video. If everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to wiring the proximity sensors to PLC S7-200 CPU222CN. Here is just an example about how to wiring the proximity sensor from the PLC S7-200 to the relay control. Yes, it means that I will connect from the proximity sensor signal to relay control and then take the contact of relay control to the input of PLC. Okay, and here is the connection terminal that I already connected the cable, and I will detail on the drawing that I already draw. Yes, in this section I will use step 7 microwin version 4 with page 9 and Vinci flexible smart version 3 to connect and simulation with the HMI. Okay, and I will use the PPI cable connect from my PLC to my PC for communication and download the program. Okay, so let's go to the drawing detail of this section. So here is the drawing of PLC S7-200 CPU222. There are two proximity sensor, PNP and NPN. The first one, I will connect the PNP proximity sensor type to the relay control Air1, and then I will take the NO contact from Air1 to I0.0. Okay, and for the proximity sensor number 2 PNP, I will connect to the relay number 2 and then take the NO nominal open of relay number 2 to input I0.1. Okay, and I will use the power supply 220 AC convert to 24 volt DC to supply to the proximity sensor. Okay, but the actual connection I will use one more NO and NC connect to the 4 inputs of PLC For relay number 1, I will use one NO and one NC. For NO, I will connect to I0.0 and NC I will connect to I0.2. And for the relay number 2 that connect from the NPN proximity sensor, I will connect to input I0.1 for NO, and for NC I will connect to I0.3. Okay, so we can go to step 7 microwin version 4 page 9 and which is flexible to create a new project for test with the actual. Okay, so this is just example about how to connection the proximity sensor NPN and PNP. Yes, so we can follow my drawing to connect to the PLC. Okay, so right now let's go to our software to create a new project together. So let's go. Okay, so right now I will use step 7 microwin version 4 page 9 for create a new project for so the signal of the PLC from proximity sensor, and the second software I will use WinCC Flexible Smart version 3 that connect with the HMI IE700 version 3. Okay, so first let's go to step 7 microwin. Okay, so first let's go to communication to test the communication between our PLC and PC. Yes, so first let's go to set the PC PG interface. Okay, I will choose the PC PPI cable. Yes, for Windows 64-bit we must choose the PPI cable patch for communication. Yeah, right now I will use the Windows. Yes, 64 bits operation Windows 7 page 1. Yes, so after install the step 7 microwin, we must install the PC PPI cable for patch the connection. Okay, so let's go to set PG-PC interface, and I will choose the USB because right now I already connected the USB cable from my PC to the PLC. Yes, and then choose communication. Yeah, double click to check the communication. Yeah, okay, right now it detects one CPU 222CN. Yes, real version 2.01. Yes, so communication is okay, and then we need to create the program for show the status of the proximity sensor, right? Okay, I will zoom a little bit. Let's go to option, tool option. I will zoom to 10 or 12. Yes, like this. So first we need to read the proximity sensor. Yeah, example read signal from proximity sensor number 1. Yes, so for proximity sensor number 1 I use I0.0 and I0.2, right? Okay, so I0.0 we will come here I0.0. Yes, I0.0, it is the NO, right? Contact of proximity sensor number 1. Example, I will turn on the Q 0.0. Yes, And for NC contact, right? NC contact, I connected to the I0.2, right? So I will choose NC I0.2, turn on the Q 0.1. Okay. And for proximity sensor number 2, I connect to the I0.1, yeah, for NO, and I0.3 for NC. Yes. So here I can use NO I0.1. Example, turn on the Q 0.3. And one more for NC I0.3. Turn on the output Q0.4. Yes. Okay. And then we can compile the program and then download to the PLC. Okay, I will stop the CPU. And then run the CPU back and we can online. Okay. So right now let's see all output is turned off because the proximity sensor is free. No object to touch them. Yes. So let's test together with me. So if we touch the proximity sensor number 1, yes, let's see the output is turned on and the PLC is turned on also. Yes. Okay. For number 2, yeah, turn on also. Yes. The status of the PLC is turned on also. Yes. Number 1, number 2, and if we touch together, yes, it will turn on together. Okay. So we need to show the signal on the HMI. Yeah, the next step. So to create the signal on the HMI to show the all this signal, let's go to HMI software. WinCC Flexible Smart version 3. Yes. And I will create the new project. And I will choose the S7-200 IEV3. It is made with my hardware. Yes. So I will choose it. And then first we need to create the connection for communication between PLC and HMI, right? So let's go to connection. Example, PLC S7-200. Yes. And for the driver, I will choose schematic S7-200 because right now we connect to S7-200 CPU 222. Yes. And here I will choose DP. Yeah, because we use DP cable. And here I will use IF1B because we have only 2 slots. One slot is Ethernet and one more slot is COM port, right? Okay. And for baud rate, I will use 9600. Yeah. And for address, the PLC is 2. Okay. So this one we can comment as communication between PLC and HMI 700 IE V3. Yes. And then next we need to create the tag, right? For tag we have I0.0, I0.2, I0.1 and I0.3, right? So I0.0 and I0.2 is for signal proximity sensor number 1. So proxy 1 NO, yes. So it will start from Boolean. So I0.0, yes. And next proxy 1 and C I0.2, right? Yes. And for proximity number 2 we can copy and then paste, and we just change this one to number 2 and start from I0.1. Yes. And for this one also we can rename this one to proxy number 2 and C and start from I0.3. okay. And for the status of output we have totally 4: Q0.0, Q0.1, Q0.3. This one should be Q0.2, right? I will rename this one to Q0.2 and this one Q0.3. Yes. Then I will download again. Actually, we can test the proximity sensor, yeah, easily. So this one proxy 1 output, right? Example out1, the boolean, and Q0.0, right? Okay. And for the out2, Q0.1. And for proximity number 2, can copy and paste and rename this one to be proxy 2 out1. So Q0.2 and this one proxy 2 out2 Q0.3. Yes. And then we can create the stator, right? Okay. So I will choose the text file. Example test proxy MIT sensors with PLC S7-200 CPU 222. Okay. And then I will change the background of the HMI to be this color, and then change this one to be yellow color, and increase the font size to be 22. Yes. Okay. I will change to 21. Yes. And then I will create the signal. Example this one for proximity sensor number 1 input, and for this one is output. We have 2 outputs, right? Proximity sensor number 1 we have 2 output. for NO contact and NC contact, right? So I will choose true output. Yes, and I will change this color to be red because it not on, right? Change to be red. So this one is proximity sensor number 1. So proximity sensor 1 input. I will change to be white color. Yes. And then change this take to be 12. Yes. So this one for input. And this one for output. Yes, like this. Okay. And for proximity number 2, yes, I will put like this. Okay. And for proximity number 2, we can copy from here. Yes, drag and drop. And then change this one to number 2. This one, number 2 also. Yes. And then we can create the color animation for change the color when the proximity sensor is touched. Yes. So the first one I will configure for signal proximity sensor number 1. So this one should be 2 signal also, right? I will put like this. Maybe put like this. Okay. And then copy again. Okay. So the first one is I0.0, right? So color animation proxy 1 NO, right? Input NO. Proxy 1 NO. I will change to be green color when it has action. And this one also proxy 1 NC. Yes, I will change to 1 green color also. And for this one is proxy 1 NO. Sorry, proximity sensor number 2 NO. I will change to 1 and change to green color. This one also proxy sensor number 2 NC. I will change to 1 and change to green color. Yes. And for this one is signal proximity number 1 output, right? So proximity number 1 output 1. I will change to green also. Actually we can delete and just like this. And then we can change only color to be output 2, right? And then we can copy. Yes, this one for proximity number 2, output 1, and this one proximity number 2, output 2. Yes, and then we can save the project. PLC S7-200 proximity sensors, proximity sensor. Okay, so I will maybe I will change the logic a little bit. Change this one to NO. Yes, for easy to see the status. If we put like this, it means that this one is green and this one is green also, right? But the output is red. Yes, so maybe I can change this one to be I0.2 for NO. Yes, so I0.2 is NO, and then delete this one also. I0.3 is NO also, and then I will download again. Okay, and then start the CPU. Yes, so when start the CPU, let's see the status is on. Yes, because I0.2 and I0.3 is connect with the NC of relay. Yes, so when node touch the object to the proximity sensor, it will turn on. Yes, because we connect with NC. Yes, and then I will download this project of HMI to the real HMI. Yes, so before download, let's check the HMI first. Yes, so let's check the communication first. So first let's turn on the power for HMI. And then go to control panel, and then go to transfer, and go to enable. Yes, first we need to enable the internet and remote control. Go to advanced. So here is the IP address of the HMI for communication with the PC for transfer. Yes, so 192.168.20.4. yeah, it is the HMI IP address. Yeah, and then let's go to OK and close. Yes, so we need to enable like this, and then close, and then click transfer. Yes, and then we can check the communication between our PC to the HMI. So we can ping 192.168.20.4. yes, So it shows like this. It means that we can communication between our PC and our HMI. Okay, so we can click download and then fill the IP address of the HMI. So 192.168.20.4. Yes, and then click this button to download. And click yes to confirm download. Yes, so wait a moment for downloading. Yeah, download finish and start the screen. And then I will connect the communication cable to the PLC. Yes. One connect the HMI will show the status. Yeah, I will show. Yes, let's see the HMI is show the status of proximity number 1 and number 2. Yes. So if we put any object to the proximity sensor, yes, the signal will change, right? So let's test. I will put the proximity sensor number 1 first. Okay, let's change. Let's see the signal is changed, yeah, between input and output. Yes. Yes. And for proximity number 2 also it changed. Yes. It changed. Yes. So communication between PLC and HMI is working properly. If I put two objects, yes, it will change too. Yes. Yes. So this is just example about how to use the proximity sensor connect to the PLC S7-200. So I think if everyone would like to use the proximity sensor to control the project, yes, we can follow my drawing, yes, that I already show in this slide. Yes, if we have input, we can take the input to the PLC and then we can create the program for test, right? So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone. Welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show about how to read data from encoder by using PLC S7-200 CPU222CN. Here is an example about how to connect between HMI to the PC and from the PC to the PLC. And here is the incremental encoder model OG71. Yes, it is the boomer brand. And I will connect the encoder to the input 0.0 and 0.1. Yes, because it is the high speed support for this input. And I will use the HMI to show the status of the encoder. When we rotate the encoder, it will show the signal here. And I will use the Profibus DP cable connect from the HMI to the PLC, and use the PPI cable connect from my PC to the PLC to communication and download the program from my PC to the PLC. Okay. And here is the signal of encoder. Phase A, B, C, A bar, B bar, and C bar. Yes. So to create the example program to read data from encoder, I will use step 7 microwin version 4 with page 9 and Win is flexible to create the project and then download to the HMI. Okay. So let's go to our software to create the new project. And in this section also, I will show the example about how to read data from encoder and then calculate with the RPM models. Yes. Okay, so let's go with me step by step. So first, let's open the step 7 microwin. And the first step, we need to check the communication between PLC and PC. So I will go to PC, PG interface, then PPI cable, and I will use USB. And go to communication tab and double click to check the communication between our PC and PLC. Yes. So right now it detects one CPU. Yes. CPU 222CN. And then we will go to set up the high speed counter, right? So let's go to Wizard tab and then go to high speed counter. Yes. And the first step, I need to show about how to read the data of encoder and with the remember the value if we power off and power on the power of PLC. Okay. So I will choose AC0. Yeah, it is the counter name. And then I will use mode 4. Mode 4 I mean that single phase up down counter with external direction control. No start input, use reset input. Okay, so if we choose this mode, we can reset the counter also. Yes. So let's click next and then next and then finish and then click yes to complete the wizard configuration. Okay. So to use the encoder, read the data from encoder, we can see here we need to use SM0.0 to trigger, yes, to call the block of HSC initial, yes. So we can go to NO and then SM0.1, yes, and then call the subroutine from here. So drag and drop. And if we would like to read the data from encoder, we can use SM0.0 all the way on. And then we can use move the word. Yes. So I will move AC0 right here. So we can copy AC0 and then move to VD. Example, the word I will use VD10. Sorry, VD10. So if we put like this, if we turn off and turn on the power, it not remember. Yes, it doesn't remember the value, right? I will show. So if I download the program to the PLC, yes, and then I will increase the encoder. Yeah, let's see the data. Right now it's 0. If I increase the encoder, the value will increase, right? And if I turn off the power, let me turn off the power of PLC. And then turn on again. Yes. And then online to see the status, it will 0, right? So to remember the value of this step, we can copy VD10 to paste here and paste here. Yes. And then download again. Okay. I will stop the CPU and then download again. And then start the CPU and then we can online. And I will increase the encoder again. Okay, the value is increased. And then I will turn off the PLC again. And then turn on again. Okay, let online to see the status. So it will remember the value. Yes. So we just copy from here and then paste here. So the value is remember. Yes. So if we would like to show this value on the HMI, we can go to create the HMI. I will create the new project and choose the Smart 700 IEV3. It is the same as my hardware of HMI. And first we need to create the connection, right? So let's go to connection, double click, and then this one example encoder connection. Okay, and I will choose schematic S7-200 because right now we use the PLC S7-200, and this one we can command as example communication read data from encoder. Yes, and here we can use the DP. Yes, actually we use DP. And then for the baud rate we can use 9600. Yes, and here is the PLC address number 2. Yes, and then we can go to create the text, right? For text here, if we would like to show the data of encoder, we can use VD10. So value encoder, I will use double integer, and VD10, right? So VD10. Okay, and then let's go to screen. I will change the background of screen to this color, and then I will use text. Example, read data from encoder using PLC S7-200 CPU 222. I will change the color to be yellow, and then increase the font size to be 22. Maybe 21 or 20 is okay. Yes. Okay, like this. And I will change to center and middle. Yes, and then I will use the value, yes, that read from encoder, right? So in this one we can use output, yes, and then choose the text, yeah, value of encoder, and this is the format. Example, I use only like this, and then we can change the color of text, color of background, and size of text also, right? Okay, I will use this color for cover the text. And if we would like to put the picture of encoder, we can go to the picture. Yes, here, example, my encoder. So we can right click, copy, and then go to the HMI screen and then paste. Okay. And if we would like to put some text, can copy, and then this one should be example double integer, I will increase the size a little bit and then change this color to be a white color. Yes. And then I will increase the size of encoder like this. So we will got like this, and then we can download to the HMI, right? So how to setting and then download to the HMI I already show on the previous video. So in this video I will download to the HMI, yes, directly, because it's the same function. I will use center and middle also. Yes. So we can download the project to the HMI. Yes. So the IP address is 192.168.20.4. Click yes to confirm downloading. Okay, download finish. So we can back to our PLC. Okay. So I will increase the encoder. Yes, and let's see the HMI together. So here is my HMI and here is my encoder. So I will increase the value of encoder. Yes. Let's see, the value is count up. And if we decrease the value of encoder, yes, the value is count down. Yes. So it worked perfectly. And if we would like to reset the counter, reset the value of encoder, we can create the logic. Example, I will use M0.0 and then make Q0.0 is turned on, and we can wiring the Q0.0 to turn on the input I0.2. Yes. So I will download the program again. Okay, downloading, and then okay, can online. So right now the output is already configured, and I already wiring the contact from the Q0.0 to input 0.2 for reset the counter. So we need to create the push button for reset the counter on HMI, right? So let's go to create the text. So reset the counter, reset encoder, and I will use boolean. and start from M0.0 and then go to screen. Yes, I will create one more button for reset the counter. Example, reset encoder here. Okay, reset the encoder, and I will use the button for red color. Yes, for reset the counter or reset the encoder. And then we need to configure, right? So go to property and then go to event and then preset. When pre, I will set bit. So set bit reset encoder, and when release the button, I will reset the bit reset encoder. Yes, and I will increase the size to be 14. Yes, and then I can move this one a little bit like this, and then we can download to the HMI again. Okay, finish, and then we can go to increase the encoder again. Okay, right now the HMI show 4, the same as the PLC. So if I increase the encoder, yes, the value will increase, yes, very fast, right? And also can decrease, yeah. And if we would like to reset, we can push the button reset here. Yeah, it will reset the encoder to 0, yes. And if we would like to increase, we can increase, and we can reset again, yeah. So reset to 0. So for create the block of high-speed counter and reset the counter, I already show. So next step, we need to see the calculation example. We would like to calculation for RPM of motors. So we can use this encoder also, yes. So I will create one more project, yes, because we need to use mode 0 for use for calculation the RPM of motor. So I will save this one first. So this one, project 1. I will drop the project under my video and everyone can download to use, yes. For HMI, I will use the same HMI, yes, so no need to save. And then let's open the step 7 microbin again and go to wizard again, and I will use mode 0 for calculation the speed of the motor. So go next and next, and finish. Click yes to complete the wizard configuration, and then I will use SM0.1 first scan, and then call the subroutine of high-speed counter. And here, if we would like to calculation, we need to use the SM0.0 all the way on, and then move the buzzword also, right? So move the buzzword. I will move HC0 also, right? So we can copy and then paste here. Example, I will move to VD10 also. Yes. So if we would like to calculate, we need to know about the rotation per second, right, of encoder. So this is just example, so I make the easy formula. Yes, I will convert this one to double integer first. Yes, so I will use double integer to real. So I will convert VD10 to VD20. It is the real, right? And then I will divide. Yes, so divide real. I will divide VD20 by resolution of encoder. Example 1020.0 pound per second. Yes, and then we will got VD30. Yes, and then if we would like to convert to round per minute, we can use multiply real. So mal real, and I will convert VD30 multiplied by 60.0 and then VD40. Yes, so if we write like this, it will increase forever, right? But we need, if the encoder not rotate, it will move the value to 0, right? So we just move the subroutine, yes, to like this. We will got 0. Yes, and for this time we can use the function increase by. Yes, example less than or equal by. Example VD0 VB0 less than 5. I will increase by of VB0 to VB0, and then for this one I will instead by if greater than or equal by. Yes, so VD 0 and greater than equal 5, then the value is working. Okay, so let's save and then download. This is project 2. Yes, RPM motor calculation. Okay, then we can download. Then run the CPU and we can online. Yes. So I will use one more for move the value to show on the HMI, right? So I will use SM0.0 and then move real. So I will move VD40 to VD50. Okay. And we need to change the HMI to be VD50, right? And the data type is real. Okay. Then we can online. Okay, so when the encoder is rotate, it will divide by resolution and then multiply by 60. We will got RPM. Yes. So in this case, if encoder is revolution is not the same, so we can change this parameter to be the same as the revolution of encoder. Okay, and then let's go to HMI and then change this one to VD50. Yes, let's go to the text. Okay, I will create one more text. Okay, so let's create the new text. Example motor 1 RPM, and then it is the real, right? So I will choose real and then VD 50. Yes, here VD 50. So let's go to the screen. Actually we can copy from here. Yes, I will decrease the picture a little bit. So this one should be real. And then I will insert the motor, yeah, from the library. Yes, go to the motor. Okay, I will use these motors. And then we need to measure the RPM of this motor, right? So this one is the real value. Yes, so I will copy and then choose the text here. Data type maybe like this. and we no need to put the reset counter, right? Because we use mode 0. Okay, we will align it. Okay, like this. So the unit is RPM. This one should be RPM, right? So RPM. Okay, like this. And then we need to create a sample. Yeah, I will save the project first. So it is the encoder, right? So HMI 1, and I will create the logic, yeah, to start the motor. Example M0.1, M0.2, and start the motor. Example Q0.1, and I will hold signal when I start the motor. Yes, then we can download. Okay, and then we can create one more take. Example start motor. I will use boolean, and then the address will start from M0.1, right? So M0.1, and this one stop motor. So M0.2, and one more is status of motor, right? Q0.1. Yes, and then we can create the screen, yeah, for start and stop the motor and change the status of the motor. Yes, so let's go to button. I will use start. I will change color to be blue color. Yes, okay, and for stop I will change to be red color. And rename to be stop. Okay, and then we need to configure the button, right? So let's go to event, freeze, set bit, start motor, and when release I will reset bit, start motor, and for the stop also set bit when freeze, stop motors, and for release I will reset bit, stop motor also. Okay, and then I will change the status of the motors when we start it. So I will use this color. Yeah, I will use the red color, and then when the status of motor is on, I will change to be green color. Yes, and then we can save, and then for this interlock I will cut off the input when the Q0.1 is not on. Okay, so I will insert one more column, and then I will copy this one and then insert the NO. Yes, and this one is NO also. Yes, so it will start check when the motor is started. Yes, so I will download the program to the PLC again. Yes, downloading, and then we can online. So motor is need to start first, right? And then we can download the HMI to the project of HMI also. Okay, finish, and let's test together. Okay, so first we need to start the motor first, right? So I will start. Yeah, right now the motor is running, and then we can increase the encoder. Yes, okay, so the value is changed a bit, but when we rotate like this, the RPM is show a bit. Yes, so if we run with the actual motor, the value of encoder is increased very fast, and RPM is show also. Yes, okay, so this is just example about how to read data from encoder, and then remember the value of encoder when we turn off and turn on the power, and basic calculate the RPM of the motor. Yes, so thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon, and I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to link data between PLC S7-200 Smart CPU SR20 to PLC S7-200 Smart CPU SR20 by using the function put and get. So before go to create the program, I would like to explain the concept a little bit. Yes. So the concept is we would like to send the data from the PLC1 to PLC2 or send back from PLC2 to PLC1. We can link by the Profinet cable that connect together to the Ethernet switch, and then we can control from PC or touch screen. Okay, and in this section I will use step 7 microbit smart software and Windows flexible smart version v3, and I will use the HMI smart line 700 IE v3. Yes, then we can create the screen for control the PLC1 or control the PLC2, followed by LAN cable that connect to the switch. Okay, and I will assign the IP address to the PLC number 1 like 192.168.2.1, and for PLC number 2 192.168.2.2, and for my PC I will assign the IP address as 192.168.2.253, and for the HMI I also assign the IP 192.168.2.3. Okay, so if we go to our PC, we can ping from the PC to the PLC1 via this IP address, ping to the PLC2 via this IP address, and ping to the HMI by this IP address. Okay, so for easy to understand, I will go step by step and slowly for easy to understand and know the concept and test with the program. Yes, so let's go to next slide. I will explain more. Yes, for the next slide here we must use the wizard for get and put function. Example, if we would like to send the data from PLC1 with the transfer size in 2 bytes, we can choose put. It means that put from PLC1 to PLC2, and PLC2 is 192.168.2.2. Okay, this one. So we will send from 192.168.2.1 to 192.168.2.2. Okay, then we send set like this. And for the memory, we can use another memory like VB, MB, etc. And this is the local address. For local address, it means that send from PLC1 the address of PLC1, and for the remote address is memory of PLC2. Okay, and then we can go to next and generate. We will got this block, and for this block it will check the time and cycle time and error. Then we can detect when, example, the network or LAN cable is loose. It will show the error, and then we can take this one to check when the error occur. It will reset the memory. Yes, then the network will cut. Okay, so go to next slide. For this slide, I would like to show about the get memory from the remote CPU, 2 bytes also. Yeah, and then we choose the function get here. For this one, we use put it means that put the some memory from PLC 1 to PLC 2, and for this one get it means that we get some memory from PLC 2 to PLC 1. Okay, and here is the remote IP address. It means that PLC 1, yes, this one. And the memory will start from V0 also, VB0, yes, and the concept is the same. So we will test together, yes. So go to our software. So first let's go to step 7 microwave smart software. Yes, open. And then if we follow our slide, we need to set up the wizard, right, by using the get and put function. So let's go to wizard here, and then we can use this one, double click, and we need to assign the name of the wizard name. Example, PLC1 data, yes. So click next. So here if we would like to put the some memory from PLC 1 to PLC 2, we can select put. Yes, let's see, when we select, the arrow sign will change the position. Yeah, this one put. And this is the memory byte that we want. Example, I would like to send only 2 bytes. It means that 16 bits. Yes. And then here is the VB. It means that memory start from VB, example 0.0 until 1.7. Yeah, 16 bit. We can also use IB, QB, MB, yeah, etc. So I will test with VB first. And here is the remote. It means that PLC2, yeah, PLC2. The IP address of PLC2 is 192.168.2.2, right? So we'll put the data from 192.168.2.1 to 192.168.2.2, okay? And the memory will start from VB0 also, yeah. And then go to next. And here is the suggest memory. So actually we can click suggest, it will automatically calculate for us, and then click next again, and then click generate. Yeah, after click generate, we will got one subroutine here. Yes, so we can drag and drop to the network, and then here is the timeout. Example, if we would like to read some help, please F1. Let's see what is the timeout. Yes, data type of timeout. Yeah, we can see cycle and error. We can read also. Yeah, so many instructions we can read and follow the manual operation of this software. It will work perfectly. Okay. So time I will set 2 seconds, and for cycle I will use some memory, example M10.0, M10.1, and here we must put the always on, right? So we can use always on. Yes, and then we can compile. Okay, no error occur, and we need to create the logic for control from PLC 1 to PLC 2, right? So the logic, it will start from VB0, right? So example, I will send data from PLC 1 to PLC 2 from V0.0 to V1.7, right? 16-bit, 2 bytes. Yeah. And then we can copy the always on here. So it will start from V0.0, right? So example, I will use M0.0, start V0.0, yes, and then M0.1 will start V0.1, yes. Okay, and then we can save our project. So I will create one folder, put get PLC S7-200 smart. Yeah, for this one is PLC 1, right? So PLC 1. Okay, and then we can go to create one more for PLC 2, get the data, right? So I will compile again. Yes, no error occur. And then we can create one more for PLC 2, got the data from the PLC 1, right? So first basically go to Visa tab and then go to get port, and here is the PLC 2 data, and then click next. So this one get, right? When get, let's see here, the arrow will go to this position, and when we select port, it will go to this direction. Okay, so right now PLC 2 is get, and then I will get 2 bytes also, right? So 2 bytes, and start from VB0 also, yes. And here is the remote IP address of PLC, right? So 192.168.2.1, right? Remote, it means that the PLC that send the data. So PLC 1, and PLC 1 is 192.168.2.1, okay. And for remote address, it will start from VB0 also. So click next, click suggest, click next, click generate. Okay, and then we can go to subroutine. Yeah, this one also. So always on. I will choose 2, and this one example M10.0, M10.1, yes. And we need to compile the program, yes, no error occur. And then we can create the command like get data from PLC1 V0.0 to V1.7. okay, so I can copy the always on from the network 1. So this one should be command as network checking. Okay, so we will get the data from the PLC1. Yes, I will open the PLC1. Okay, open like this, easy to understand. Yes, so here is the PLC1. So I will send V0.0 to PLC2, right? So PLC2 will get we get 0 V0.0, right? So V0.0 example send to output U0.0. Yes, and V0.1 will send to output Q0.1. Yes, then we can compile error 0. Yes, then save. So this one should be PLC2, right? Okay, so I will put PLC2. Okay, and we need to download this program to PLC1 and this program to PLC2, right? So first we need to put the computer IP address, yeah, the same as my slide that I already show here. So 192.168.2.253, yes, otherwise we cannot ping, right? So we cannot ping 192.168.2.1. okay, we cannot ping. One more, 192.168.2.2. yeah, we cannot ping also. Okay, if we cannot ping like this, we cannot download the program from our software to the PLC also, right? So we need to put the manual address of my PC here. So I will put 192.168.2.253. yes, subnet mark 255.255.255.0. then we will try to ping again. Yes, so we can ping for PLC1 and for PLC2 we can ping also. Yes, so it means that we can connect. So first we can download the program to the PLC number 1, right? So let me go to the communication here and then choose the correct adapter here. Yes, my network adapter. Okay, right now it detects two CPU. One is 192.168.1.2.1, right? And number 2 is 192.168.2.2. yes, the PLC2. So right now I will download to PLC1, right? Because I write PLC1 here. So click on the PLC1 and then click OK. and then we can click download. Yes, download to PLC 1, right? Stop the CPU. After that, we can go to run the CPU. Yes. And then we can online. Yes. Okay. Can online. So let's see, here is cycle memory. Yes. Actually, we can take this bit to the HMI to show the cycle also. Yeah, let me show after this download complete. So right now we can go to download this program to the PLC2, right? So I will go to communication again. Go to find the CPU. Okay, and then I will select PLC2 192.168.2.2. Yes. Then I will download the program to PLC2. Then I will start the PLC2. Yes, and we can online. Yes. Let's see here, the communication is okay. Let's see, the cycle time is blink. Yes, it means that the communication is working properly. And for the error is 0, it means that no error, right? We can read from the health here. 0, it means that no error. Yes. Error, check instruction. Yes. Code number. And we have also the code for error. Yes. So right now it's working. So let's test together. So if I write the M0.0 from here, V0.0 will turn on, and then the PLC2 will turn on also, right? Output will turn on because we already link. Let's see here, it work. I will turn on one more. It work. Yes. So the communication is work properly. Yes. And if we would like to stop, we can also write stop. Yeah. Write stop. Okay. And we can add more until bit number 0.v0.2 until v1.7, right? So let's add more for PLC number 1. Yes. M0.2 start v0.2 M0.3 start v0.3 M0.4 0.5 0.6 0.7 so this one will start the v0.3 M0.3 M0.4 v0.4 so this one M0.5 v0.5 M0.6 v0.6 M0.7 v0.7 and for the 8 bit more, right? So it will start from M1.0, control the V1.0, .1, .2, .3, .4, .5, .6, .7, yes, and we can connect. So M.1, this one should be M.1, right? V1.1, M1.2, V1.2, M1.3, V1.3, M1.4, V1.4, M1.5, V1.5, M1.6, V1.6, M1.7, V1.7, right? Okay, so totally 16 bits, yeah, 2 bytes. Then we can save the project and then download to the PLC. And we can online, yes. So for PLC 2, we also create, yeah, the same as the PLC 1, yeah. So I will outline first, and then we'll copy V0.2, control the output number 2, 0.3, control output number 3, yes. V0.4, control the output 4.5, control output 5, six, control output number 6, one more, V0.7, control output number 7, right? Okay, it's just 8 bits. So the CPU SR20, it has only 8 bits for output. So we can use one more for %m. So example V1.0, it will start from M, right? Example M 1.0, yeah, I will start from M 1.0. Sorry, paste here. So V1.1, M1.1, .1, .2, .3, .4, .5, .6, .7, yes. Okay, so this one I can copy also. Okay, and then this one should be V1.2, right? This one V1 M1.2 V1.3 M1.3 V1.4 M1.4 .5 M1.5 V1.6 M1.6 V1.7 M1.7. Okay, so 16 bits also. Yes, then I can delete this. Yes, and we can save the project and then download to the PLC. After that, run, and we can online. Yes, so let's see PLC number 2 and number 1. Yes, I will put like this. And then if we would like to forward the signal, yes, okay, right on. Let's see, bit on, right on, this one on, right 2 on, this one on, the last bit. So we can go to the last also. Yes, yes, this one on. Okay, then we can create the safety example. Right now, if I take out one more cable of Ethernet cable, yeah, this one LAN cable, it will no action, right? Let me show. It will no action. It means that the output of this PLC is still on. Yes, no action if we disconnect the network. Actually, if we disconnect the network, it will have action, right? This output will turn off, right? I will test. Let's see here. I will disconnect the cable from this one. Disconnect the network cable. Yes. Let's see, the output of PLC 2 is still on, right? It's still on. So communication lost, but the output still on. So it's not correct, right? So we need to create the safety. Yes, if the network is cut, let's see. If I take out the network again, the communication will error, right? It will error the cycle time. Yes, it not have the cycle, right? Because lost communication. Let's see, the error is occur. Change from 1 to, sorry, change from 0 to 1, right? Because we already disconnect the cable, LAN cable from PLC 2. Yes, but the output still on. The output of PLC 2, let me show. let's see the output of PLC2 is still on, but the LAN cable I already disconnect from the LAN port. Yes. So it doesn't correct. So to correct the function, if we take out the LAN cable or unplug the LAN cable, the output of PLC2 will turn off, right? So we can go to the PLC2, yes. Then we can create one more. I will insert this network. Okay, insert one more network. Okay, insert the network. So when M10.1 is turned on, it means that it won lost communication, right? So I will move by, right? Because we use the by memory, I will move 0 to VB0, right? And also move 0 to VB1, yes. Okay. And for the PLC1, we can also modify, yes. So it lost the communication, yes. This one we can command when lost communication, then it will reset the value of data, right? So if M10.1 is turned on, then I will move 0 to this one, right? VB0. So VB0, and also move 0 to VB1. Okay. Then we can save and then download. Okay. PLC1, and we will go to the PLC2. Save and then download. Okay, and then we will test again. So now let's see, the error is 0. It means that no error occur, right? So let me take out or unplug the LAN cable again, and then let's see the output of PLC2. It should be reset, right? Okay, So right now I will unplug the LAN cable from PLC 1 again. Yes, let's see when I unplug the output will is turned off, right? Okay, it means that lost communication between PLC 1 and PLC 2. Yes, so the output is turned off. Okay, so that's correct function. And we need to create the HMI for test, right? So let's go to HMI, WinCC Flexible Smart version 3. Create the empty project. Yes, and I will use Smart 700 IEV3. It is the HMI. Yes, my HMI. So I will choose this one. So first we need to create the connection, right? Okay, create the connection. Then we have two PLC that we want to control, right? Example PLC 1 and choose the driver. I will connect to PLC S7-200 Smart. Yes, this one. And one more for PLC 2, right? Okay. And between PLC 1 and PLC 2, we must choose the port that we want to connect from the HMI to PLC. So right now I will use Ethernet. So here is my IP address of my PC. So 192.168.2.253, right? And for the PLC 1 is 192.168.2.1. Okay. And for PLC 2, I will choose Ethernet also. And the IP address, my PC is the same, but the PLC is changed to 192.168.2.2. Yes. So that's okay. And then we need to create the text, right? We need to create the text. So to create the text, let's see here for PLC 1. Yes. PLC 1, it will start from M0.0 until M1.7, right? Okay. So we can go here. Example PLC 1 M0.0. The driver is PLC 1, right? And then the data type is Boolean and start from M0.0. Yes. Then we can draw like this. Delete this one. Yes. And one more for the V memory stator, right? V memory stator, it will start from V0.0 until V1.7, right? So PLC 1 V0.0. The driver is PLC 1 Boolean, and I will choose V 0.0. Yes, 0.0, and then we can drag like this. Yes, and for PLC 2 we also must create the text also. Yeah, it will start from V0.0 until V0.7. Yes, so PLC 2 V0.0, and this driver I will choose PLC 2, and it will start from V0.0. Okay, and then we can drag like this. Okay, and for PLC also we have the output, right? Start from Q0.0 until Q0.7, right? So PLC 2 Q0.0, the Boolean, and for the driver we choose PLC 2, data is Boolean, start from Q0.0. Then we can drag like this. Okay, delete one. Yes, that's all for create the text. Then we can go to the screen. Okay, we can save the project. I will put here. Yes, this one HMI put get. Okay, and then we can create the screen. Example, I can separate the part, two part, one part for PLC 1 and one more part for PLC 2, right? Okay, like this. And then I will increase, yeah, for separate the part. Okay, and then this one for PLC 1, right? Okay, I will choose text. So PLC 1 data, I will use ball, and I will increase the size. I will change the background to be this color, and for this one I will change to green. Okay, then we can copy for PLC 2. Yeah, PLC 2 data. So we need to control from the PLC 1 to PLC 2 by using the M0.0 until M1.7, right? So I will create the button. Yes. Example, we can test only 4 or 5 bits. It's okay because it is the same. Yeah. Example, I will test only 4. Yes. Test only 4 bit. Okay. We can test only 4 bit first. For send the data from PLC 1 to 2, yeah, by controlled by HMI. So this one we can write bit 1, this one bit 2, this one example bit 15. This one should be bit 16. Yes, we can align. So I will change this button to be some color, example the blue color. Okay, this color or another color that we want, right? Okay, this color. And we need to see the status of this one also, right? Yeah, this one. So I will put lamp. Okay, this one for lamp 1. Then I will change to this color, and I will change the color animation when bit PLC 1 V0.0 change, right? Okay, and I will change to green when the logic is 1. Yeah, it means that true. And then I will copy 3 more, and then we can align. Yes. Okay. And this one we can change the V0.1. This one we can change V1.6, right? V1.6 have or not? This one should be 1.6, right? V1.6. Let me check the text again. V1.6. PLC 1 V1.6. Not yet created, right? V1.6. Okay. Then we can create PLC 1 V1 1.0 PLC 1 data, right? So V1.0 until V1.7, right? So drag. Okay, until V1.7. Okay, go to the screen again. So this one should be V1.6. Yes. And then this one should be V1.7, right? Okay. And for the PLC number 2, we can copy from here. Yes. So basically we can change only PLC 2, right? PLC 2 PLC 2 V1.6 not yet have, right? So I will create for PLC 2 V1.0. This one should be select for PLC 2. I would like to stick this one, yeah. Be careful when we select the driver. If we select the wrong driver, it means that we control the wrong HMI to PLC, right? So be careful in this step. So it will start from V1.0 until V1.7, right? Okay, V1.7. So go to the screen, and then this one should be PLC 2 V1.6, right? This one PLC 2 V1.7. Okay. So we can save the project and then we can simulation. Yes. Okay. When we simulation, let's see the bit is turned on here. Yes. So let me turn off. Okay, we can check the communication. I will outline first. And then check the communication. Let's check the PG-PC interface again. Okay, let's close and then online again, and then we will simulation again. This one no action, right? Because we not yet config the button. Yes. Then we can go to config the button. Yes. Go to event, please, or we can click in the invert bit. Yes. Invert bit PLC1. Yes. PLC1 underscore M 0.0, right? This one. And for bit number 2, I will invert bit also. So PLC1 M 0.1. This one should be invert bit also. Invert bit M PLC1 M. Let me check the text again. Maybe not yet create, right? Okay, M 1.6 not yet create, right? So I will create the text first. So PLC1 M 1.0, right? This one should be selected for PLC1, and the boolean start from M 1.0. Okay. Okay, good. Back to the screen again. So this one should be PLC1 M 1.6, right? This one should be invert bit. So PLC1 M 1.7. Okay. Then we can save. Can simulation again. Okay. Then we can click here. Yes. Turn off. Turn off. Turn on. This one, right? This one. Turn on. Yes. Turn off. Turn on. Turn on. Turn on. Turn on. Yes. So we can simulation. Yes. From PLC1 to PLC2. And if we would like to send the data from PLC 2 to PLC 1, we can also do it, yeah, the same as the procedure. Yes. So this is just an example about how to create the data from PLC by using the put and get function. Yes. So right now let me download the project to the HMI, to test on the HMI. So to download to the HMI, let me ping 192.168.2.3. Okay, we can ping, and then we can click here to download. Then we will choose this one and then put the IP address 192.168.2.3 to the HMI, right? And then we can download. Okay, finish. So we can simulation here, and then we can go here to check. Actually, we can use all of this bit, yes. But this is just example, so I test only 4 bits, yeah. So right now, let's go to our HMI to test. Yes. Okay, right now I will push the button here. Let's see. The output is turned off when I push. Yes. This one is off. Turn on. Turn on. Yes. So the communication between PLC 1 and PLC 2 is working properly. Okay. So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to setting the HMI control to PLCs. Okay. Now I have only one HMI model Smart 700 IE V3, then connected the LAN cable to the Ethernet switch, to the switch hub, and I will connect from the switch to PLC by using the LAN cable. Yes. So the concept is, if we would like to control the data from the PLC to the HMI or from the HMI to the PLC, so we can setting the HMI setting, and then we can download to the HMI by using the software PLC Flexible Smart version 3. And if we would like to create the program inside here, we can use the step 7 microwin smart. Okay, so the benefit of this project is we would like to integrate the data from the two PLCs by using only one HMI. Okay, and then we can control and test with me together. Yes, so here is the IP address of PLC 1, example 192.168.2.1. For PLC 2, 192.168.2.2. And for the HMI Smart 700 IEV3, I will setting with the IP address 192.168.2.3. And for IP my PC, IP address of my PC, I will set 192.168.2.253. So if we would like to test the connection, we can ping from my PC to the HMI to the PLC 2 to the PLC 1. Then we must can connect. Okay. So we will download and upload the program from the PC to the HMI and to the PLC by using the LAN cable. Okay. So let's go to create the project. On PLC S7-200 Smart first for PLC number 1 and PLC number 2, and then we will go to the VCC Flexible Smart V3 to create the example project and then download to the HMI. Okay, and then we will control the motor number 1 to PLC number 1, the motor number 2 to PLC number 2. Yes. So let's follow me step by step. Yes, together. Let's go. Okay, here is my software. Step 7 Microwin Smart version 2.5 that I already installed on my PC. And here is the WinCC Flexible Smart version 3. I already installed to my PC also. Yes. So we will use these two software to configure and download the project to the HMI and the PLC. Okay. So first we need to put the manual address of our PC to be the same as my slide. So I will put 192.168.2.253 on my PC. So let's go. IP4, yes. So if everyone not yet put, it become like this. Yeah. And if we would like to put the manual, we can use follow IP address here. So 192.168.2.253 and subnet mask is 255.255.255.0. Okay. And we will create the project of CPU 1, right? So let's open the WinCC Flexible, step 7 Microwin Smart. And first we need to check the communication between our PC to the PLC, right? So right now I will use the CPU SR30 because it is my PLC 1 CPU SR20. Yes. And for CPU 2 is CPU SR20 also. Yes. So I will put CPU SR20 here. Okay. And then for the IP address for communication for CPU number 1, I will put 192.168.2.1. Yes. And subnet mask 255.255.255.0, because here is the my IP address of my PLC. Yes. And then for the startup, we can run the CPU after power on. Yes. And here is the input and output of the CPU. Yeah. There are 16 for input and there are 8 for output of this module. Yes, and for security we can put the password or anything. Yes, so right now I will keep like this first, so only set the IP address of the PLC1. Yes, and then we need to check the communication after we after we created the program, right? So basically I will use the command sample test logic from CPU1 from HMI to CPU1. Okay, and here I can use NO contact. Yeah, example I will use M0.0. Yes, and M0.0 I will control the output Q0.0. Yes, and for next I will use M0.1 control the output Q0.1. Yes, because there are 8 outputs, right, for the CPU, so I will use until H. Yes, so example M0.2 control the output Q0.2. This one we can also bit 1. Yes, this one bit 2. PLC1 bit 2, PLC1 bit 3, and this one M0.3 control the output Q0.3. So this one should be PLC1 bit 4, right? Okay, so this one PLC1 bit 5. So I will use M0.3 control the output Q0.3. Q0.3. and this one PLC1 bit 6, right? So we can use M0.5 control the output Q0.5. PLC1 bit 7. So I will use M0.5 0.6, control the output Q0.7 0.6, sorry, and for this one is PLC1 bit H, right? So the last one I will use M0.7, control the output Q0.7. Okay, so the output only 8 bits for this CPU, so let's keep like this first, and then we can save the project. Yeah, example PLC1. Yes, and then we will create one program that we'll use for PLC 2, right? Okay, so I will open one more for step 7 microbit smart, and then I will go to set the CPU also, right? So this one my CPU is SR20 also. Then the IP address I will set 192.168.0.2. Some name mark the same. And for the input and output, yeah, it is the same as the PLC one because the specification is the same. And then for the startup, I will run the CPU also. Yes. And for the program, we can edit anything that we want. Yeah. Example, I will use command control data from HMI to PLC 2, right? Because it is PLC 2. So basically we can use the logic the same as the PLC 1. Yeah, example M0.0. We can also create like this. I will use like this SM0.0, and then this one M0.0, control output Q0.0. So this one we can copy like this. This one we can write from bit 1 to bit 8. Yes, and this one we can copy also, and then just change this one to M0.1, and this one output 1, right? Then we can connect, then we can write until M0.7, right? 0.2 Q3. This one should be output 2, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, right? Then we can use control, press control on keyboard and arrow key up, and then we can revise this one to M0.3. This one should be 3, M0.4, copy and then paste. So this one should be 4, M0.5, and this one should be output 5. So M0.6, this one should be 6, right? M0.5, sorry, M0.6, this one should be 6, and the last one M0.7, output number 7, right? And then we can compile the program. Yes, so there is no error, right? And then we can save our program. So I will save with the PLC2. Yes. So right now PLC1 and PLC2 we already created the logic, the sample logic for test. Yes. Here for PLC1 and here for PLC2. Okay. And then we need to download to the PLC, right? So right now I already connected the LAN cable from my PC to the PLC. So we can ping, right? CMD ping 192.168.0.2.1. Okay, so we can ping for PLC1. And one more, we can also use CMD ping 192.168.2.2 for PLC2. Yeah, we can also ping because we already set the IP, right? Then we can download. Okay, we can go to the communication here, then select the adapter of the Ethernet port that we already connected the LAN cable with the PLC. Okay. So basically we can use the TCP/IP auto. Yes, and then we can search. Okay, so right now it found two PLCs. The first one is 192.168.2.1, and here is the MAC address of the PLC. We can see on the nameplate of the PLC, or we can click plus like this. When we click plus line, it will show on the PLC. Yes, I will show. Okay. Let's see if I click apply. Let's see the CPU, the LED is bling, right? Yes, for CPU number 1. So we can select the CPU number 1 and then download. Click on download. Yes, because right now let's see here, we already connected the CPU number 1, 192.168.2.1. Yes. So we can select and then download, and then click download. And then we can online and then start CPU. Yes, right now the CPU running. Yes, and for the PLC number 2, we can also go to the communication. Yes, and then search the IP address of the PLC also. Yeah. Click find the CPU and wait a moment for finding the CPU. Yes. So right now it found 2 also because we use only one Ethernet card. Yes. So click the CPU number 2 and then click OK. And then we can go to download button, stop the CPU and then run again. So here is 192.168.2.2. It means that connect to the CPU number 2 also. Yes. So all CPU is running right now. All PLC is running. So we need to control this project from the HMI, right? So we need to create the project on HMI. So let's go. I will minimize this first. And then open the WinCC Flexible Smart version 3. Yes. We will create step by step. Yeah. And go to create the empty project here. Click here. And choose the HMI to be the same as our HMI, right? So right now I will use the 7-inch. So my HMI is Smart 700 IEV3. Yes. If we not use V3, we can use this one. If we use V3, we can use this one. Okay. So my HMI is V3. Okay, I will show here. Yes, V3. So I will use Smart 700 IEV3 here. And then here is the version. We can use the version, yeah, another version that we want. Right now I will use version 3.0.2.0 and click here to create the new project. Yes. Okay, so right now the screen, let's see here, Smart 700 IEV3 already created. Yes. So for the background, we can change the background, another background that we want. Example, change to the red color, to the yellow color, to this color. Yes. So we can change it. And it has many features that we can use. Example, symbol. We have many symbols that we can use here. Symbol factory, right? So here many symbol, yeah, example chemical, machinery, or pumps, or motors, valve, yeah, tank. So many objects that we can use from here. Yes. The same as my slide, I will create like this also. Yeah, motor. So first we need to test the bits, yes, that we already created here, yes, from PLC 1 and PLC 2 from the HMI, right? So right now I will go to the objects and then I will like this, make like this to separate the HMI, yes. Example, this one for PLC 1, yes. So I will go to property and then increase this one and I will change the color to be red. Yes. So this one for PLC 1, I will choose text and then we can write by property, go to the text, example PLC1, PLC1 path, yes. So here I can change the size to be okay like this. If we would like to use the bold italics, we can use, yes. And we can also change the color. Example, we change to yellow, yes. And we can adjust the font size 48, yes. Okay, 48. And this one we can copy to be a PLC2 part, yes. Actually, we can simulation, yeah, to see the text that we already created is okay or not before download to the HMI, yes. So it's good. And then we will continue to create the text on connection, right? So first let's go to add the connection. Go here for this tab for connection. So right now we have two PLCs, right? So I will add for PLC number 1, PLC 1 data, and I will choose the schematic S7-200 smart, yes, here. And for the interface I will use Ethernet, yeah. And here is the IP address of computer. One 192.168.2.253, yes. And for the PLC 1 is 192.168.2.1, yes. So I will put 192.168.2.1, yes. And one more for PLC2 data, right? So here PLC2 data, and the IP address of computer is the same, but this one should be changed to 2, right? Because here 192.168.2.2, yes. So in this step is very important. If we don't know how to setting the IP address of this module, it will not work, right? So here, so PLC 1, let's see here is 192.168.2.1, and for the PLC 2, 192.168.2.2, okay. And for the IP address of my PC, I will fix the same as the PLC 1 and PLC 2, right? And then we can save the project. Okay, then we can save. So right now for the connection, we already connect for HMI 1, connect to PLC 1, HMI 1, connect to PLC 2. So we need to create the text, right? So let's click here to create the text. For text, we already define here for PLC1, right? Let's see. We will start from M0.0 until M0.7, and for Q it is the status. When we push the button or switch, the output is turned on also, right? So we need to show the status of output on the HMI also. So we will start from Q0.0 until Q0.7. Okay, so we will create the text, follow this step. I will put like this. Okay, so first I will start from PLC1 M0.0, right? So here is the connection that we need to know and choose the correct connection. Otherwise, when we choose the wrong connection, when we control to the PLC1 example, but here we choose the PLC2, then the data will wrong control, right? So let's check here is make sure we choose the correct connection of PLC that we would like to control, right? Okay, so right now I will put PLC1 data, yes, and the data is Boolean, and start from M0.0, right? So M0.0, I will choose M0.0, okay, and for the M0.1 until 7, we can drag and drop like this. Okay, so M0.0 until M0.7, right? So this one I will delete, this one I will delete, yes. So we can keep like this. And then for the output, we also create the status for show on the screen, right? So it will start from Q0.0. So here PLC1 Q0.0, then the connection is PLC1 also, PLC1 data, and here it will start from Q0.0, right? And then we can make like this also, yes. So it will start from Q0.0 until Q0.7, right? Okay, so for the take of the PLC1, we already create on the HMI. So here we can go to the screen, yeah, go to our screen. And then we need to create the button or switch and create the lamp for show the status here, right? So basically we can go to the button here. I will use the small button, or we can use like this. Okay, I will design first and then copy to a switch or a button. So let test here, example bit 1. Okay, bit 1, we can copy for bit 2, copy for bit 3 and bit 4. And we can copy bit 8, right? Okay, we have 8 bits for test here. So this one I will change to be bit 1 until bit 8. Okay, bit 1, this one should be bit 2, right? This one should be bit 3. This one should be bit 4. This one should be bit 5. Bit 6. Bit 7. Bit 8, right? We have 8 bits. And then we also have 8 status, right, for output. Yes, here. So I will use like this. Yes. Then copy. Maybe we can increase to bigger than this one. Yes, just copy by press Control and drag. Okay, then we can arrange. Basically, we can click Shift and then click here and click like this. Then we can arrange. Yes, we can arrange to be like this. Okay, so we can copy also for PLC number 2, yeah, because we create the same as this one. So here we can drag like this. Okay, we will go like this for PLC number 2. So right now we need to configure the switch and the status of bit on the PLC number 1, right? So I will go to event, click, and then invert bit. So bit PLC 1 M0.0, right? PLC 1 M0.0 here. And for bit 2, we can also invert bit. PLC 1 M0.1, right? We can do the same as the procedure. So invert bit PLC 1 M0.2, this one, invert bit PLC 1 M0.3, input bit PLC1 M0.4, input bit PLC1 M0.5, input bit PLC1 M0.6, the last one, input bit PLC1 M0.7. Okay, so that's all for button configuration. Yes, and then we can configure the status of the lamp also, right? So let's go to the animation and then choose the text, this one, and we can type also M PLC1 underscore Q 0.0 right here. So bit, and when it 1, it means that it's true. I will change the color to be green. This one also PLC1 Q0.1, yes, bit also, and when it 1, I will change the color to be green. PLC1 Q0.2, bit 1, change the color to be green. PLC1 Q0.3, when it's true, I will change the color to be green. PLC1 Q0.4, when it's 1, it's true or it's on, I will change color to be green. PLC1 Q0.5, yes, when it's 1, I will change the color to be green. This one PLC1 Q0.6, when it's 1, I will change the color to be green. The last one for PLC1 Q0.7, bit, when it's 1, I will change to green. Okay, and then we can save the project. Basically, we can simulation before download this project to the HMI, right? So we can simulation to see the status of our button and our lamp. Yes, so here we can also click. Yes, when I click, the PLC is turned on. Yes, let me show when I click. Okay, when I click the button, let's see the PLC is turned on. Output, I will click more. Yes, turn on, turn on, turn on, turn on, turn on, and turn on. So 8-bit is already turned on. Yes, and also we can turn off. Yeah, we can turn off from the simulation. Yes, So we need to do the same as the instruction here for PLC2. Yes. So I will close first. I will turn off for all bit. And then we need to create the text for PLC2, right? So go to the text. Okay. So this one we should start from PLC2, right? PLC2 underscore M0.1, sorry, 0.0. And here is very important, so we must use the PLC2, otherwise we control the wrong location. Yes, so I will choose the PLC2 data. It is the boolean and start from M0.0 also, right? So here we can draft. Okay, we will got like this from M0.0 until M0.7 of PLC2 here. Yes, PLC2. So we have M0.0 until M0.7 and Q0.0 until Q0.7. Yes. So for M we already created it, and then we can go to PLC2 underscore Q0.0, right? The connection is use PLC2, the boolean, and the address will change to Q0.0. Yes. And then we can drop, yes, 4, right? 5, 6, 5, 6, 7, yes, enough. So Q0.0 until Q0.7. Okay. And then let's go to save the project again. And here actually we can delete first because we already config here. Then we can delete, just change the name, right? I will select and then copy. Press on the keyboard Shift keyboard and then click. And we would like to copy, just press the Control on keyboard and then drag the mouse. Yes, we will got like this. So here for the bits and for the lamp, bit button and lamp is the same, right? For PLC1. So we just go to change here. Change to PLC2, yeah. We will go like this. Change to PLC2. 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 And for the status also, yeah, go here, animation, this one, PLC2. PLC2. the last one is PLC2 also, right? Okay, so that's all, and then we can save the project and we can simulation. So for the PLC2, we can click here, bit 1. Let's see, this one PLC1, right? So I will open the PLC2 here. Bit number 1 is turned on, and then the PLC is turned on also. Let me show the status on PLC. Yes, the bit number 1 of output is turned on right now, PLC2. So if I push more button or more switch here, turn on. Number 3 is turned on. Number 4 is turned on. Number 5 is turned on. Number 6 is turned on. Number 7. Turn on, and number 8 is turned on. Okay, and we can also turn off the bit, each bit that we want. Yes, so it works. Then we will download this project to the HMI, right? So I will close the runtime first, and then we will download this project to the HMI. But before download to the HMI, let's go to setting on HMI first. Let me show. So to download to the HMI, first let's go to control panel, and then go to the transfer. So we need to enable this function, otherwise we cannot transfer from our PC to the HMI. Yes. So if like this, we cannot transfer, right? So we must put like this, then click OK, and let's go to see the set the temporary IP address here. So right now the IP address of this one is 192.168.2.3. Yes. So if we would like to modify some IP address like .3.3 like this, we can modify. But right now I will use .2.3 to be the same as my PLC 1 and 2 here. Yes. And then click OK to confirm. Yes. And then click transfer. Yes. And let's go to our PC. So I will download the project from my PC to the HMI, right? Okay. And then we can go to this button. And here is the setting. Yes. So we need to put the IP address of the HMI, right? So 192.168.2.3. Yes. This IP address. And no need to tick this one and this one. So just click here for transfer. Okay, finish. So I will show the status on the HMI. So here we can also online. Okay, runtime like this. Simulation also. So here we can put like this for CPU 1 and CPU 2 of PLC, and here is the screen HMI. Yes, so we can put here the HMI, the real HMI is also working. Yes, okay, we'll put like this, and then we will control from the actual HMI, right? So let's see, here is the HMI. Okay, let's see, here is the project of HMI that we already download. Yeah, so we can press here to control. Yeah, let's see, the PLC 1 is turned on. Turn on. Yeah, turn on. Turn on. Turn on. And turn on, right? So if we would like to control the PLC number 2 here, yes, I will push. It will turn on. Push number 2, turn on. Number 3, turn on. Number 4, number 5, number 6, number 7, and number 8 is turned on. So right now the PLC 2 and PLC 1 is turned on, and the HMI is show the status also. Yes. And then we can create the more feature that we want. Yes. Example, I will create one more program for control one motor. Yes. So here I will start from example. I will start from M0, sorry, 1.0. M0, sorry, example M5.0. Yeah, for motor 1. Insert the column, and here I will use stop. So M1.1, and I will hold the signal here M5.0. Yes, and then we can download to the PLC 1 and then start again. We can online. Yes, and we need to create the text on the HMI, right, for control the motor. to create the text, let's go to the text. So I will start from M1.0, right, for start. So this one should be PLC1 M1 start, and here we need to select for PLC1, right? So it will start from M1.0, and this one for stop, right? M1.1, and for status of the motor 1 is 5.0, right? So PLC1 M1 status M5.0, yes. And for the PLC number 2, I will create the same as this one, yes. So we can copy and then paste, and we just change this one to be PLC2, and this one should be changed to 2, PLC2 also. This one should be changed to PLC2 connection, and this one should be PLC2 also. I will change the connection to PLC2 data, yes. And then we can create the new for start and stop the motor, right? Example, this one for start. And this one should be red color, right? And I will change the size of the text to be 24, and then we can copy here, for stop, right? Okay, start should be green and stop should be red, right? So I will rename this one to be stop. Okay, and then for motor we can go to the symbol to create the symbol here, yes. Actually we can go this step, yeah. We can go to this step and then go to the symbol factory graphics, and then go to symbol factory here, and then go to choose the motors or pump or another symbol that we want. So right now I will use the motor, yes, drag and drop the motor to put here, yes. And I will put the status of the motor, right? So I will drag and drop one more motor to the PLC2. Okay, I will use this style. Okay, and then go to the symbol, and I will use like this for status. When motor run, should be change the color to green, right? So basically I will use red color for not run. So this one should be a config also for this button. So start, let's go to event and then go to preset. Yes, it means that set bit and then set bit PLC1 start, right? PLC1 M1 start. Yeah, PLC1 M1 start here. And for the release, we will reset bit, right? PLC1 M1 start. Yes, because when we push the button, it will be hold. Okay, so we can press and release. Yes, so set and reset bit, and this one also when we press set bit PLC1 underscore M1 stop and release reset bit PLC1 M1 stop, and we can also show the status of the motor when run, right? So go to PLC1 M1 status bit. I will change to 1 and change to green color. Yes. So we need to create the program on the PLC S7-200 Smart software to create this motor also, right? So let's go. So I will offline for PLC2, and then I will create the network number 2, control the motor from HMI. Yes, and then I will use start M1.0 stop, sorry, M1.1 for the status M5.0, and I will hold the signal when M5.0 is turned on. Then I will download. Okay, and then go to the HMI again, and we can copy from this one and this one. So click Control on the keyboard and then drag the mouse. We will go like this. Okay. For the button start, I just change this one to be PLC2, right? And this one also PLC2, because we already created the text, right? This one also PLC2. Yes, and this one PLC2 also. Go to animation, just change the text to PLC2. That's all. And then we need to download the project to the HMI also, right? So I will simulation first to check the status. Okay, we can please. We we can please start. Yes, can please stop, start, stop. For PLC 1, you can also please stop, start, stop, start. Okay, it worked properly, so we can download the project of HMI to the HMI. Yes, let's download again. Yes, it will update the screen. Okay, finish. And then this one we can online simulation. And for PLC 2 I will drop to here, and PLC 1 I will put here. Okay, then I will online like this. Actually we no need to online like this, it will work also. Yes, so let's control the logic from the HMI. So for motor number 1 I will stop. When I stop here, the simulation will stop also. I will start, it start. And for motor number 2 I will press start, it will start. I will press stop, it will stop. Yes, so it works properly between both PLC and only one HMI, right? So this is just example about how to create the program for test two PLCs with one HMI that I already showed step by step about how to create the project of step 7 microvin smart for PLC 1 and PLC 2, and also create the WinCC smart program for control the PLC by using the HMI. Yes, so this is just concept. So if everyone have the project, we can design. Yeah, we can use another style that everyone would like to design. Yes, so thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time I would like to say I'm sorry if I have mistake in this video, and bye bye, see you next videos. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to control the data from only one HMI model Smart 700 IE V3 to 3 PLCs. Before go to create the new project of Step 7 Microvin Smart and WinCC Flexible Smart, I would like to explain the concept a little bit. There are three PLCs model Schematic S7-200 Smart, CPU SR20 for PLC 1, and for PLC 2 I will use Schematic S7-200 Smart but CPU SR30, and for PLC 3 I will use Schematic S7-200 Smart, CPU SR20 also. Okay, and I will connect the Profinet port from those PLC to the switch, and then set the manual IP address of PLC 1, PLC 2, and PLC 3, the same as I show. Example, PLC 1 I will set 192.168.20.1, PLC 2.20.2, PLC 3.20.3, and for HMI I will set .20.4, and for my computer I will set .20.253. Okay, and the concept is we can separate the page of the HMI that I will show step by step about how to create the connection. If we would like to control from the HMI to PLC 1, we can use the connection for PLC 1. If we would like to control the data to PLC 2, we can also set for connection for PLC 2, and we can separate the page one by one to control. Yes, I will show step by step during we create the project of step 7, Microvin Smart and Schematic WinCC Flexible Smart version 3. Okay, so this is just wiring. So if we connect like this, it means that we can communication between our PC to the PLC 1, PLC 2, PLC 3, and also HMI, because the IP address is the same as class, right? So this is just concept. So let's go to create the project step by step and easy to understand. Okay, so let's go to follow me step by step. So here is the software Schematic WinCC Flexible Smart and step 7 Microvin Smart that we will use to create the project. Okay, so before go to create the project, I will create a new folder. Example 1 HMI connect to 3 PLC, right? Okay, and then we will create the project and then download to the PLC 1, right? And I will explain how to set the IP address and set the CPU status. When we power on and power off, the CPU is running or stop or last. Okay, so let's go to open step 7 Microvin Smart. Okay, so here is the default program. When we open the software, we will got the window like this. And first, we need to insert the CPU, right? So the CPU one, I will use CPU SR20. Yes. So let's go to insert the CPU SR20. Yes. And for the startup option, I will use run mode. If we select run, it means that when we power on, it will run the CPU. And if we choose stop, it means that when we off the power of PLC and power on again, the CPU will stop. When we select last, it means that when we run the CPU and we turn off the power of CPU, when turn on again, it will run because it remember about the last. Okay, so basically we can choose run because actually when we power on, it will allow PLC to run, right? So let's choose run and then click OK. And we can communication between our computer, yes, to PLC, right, to check communication. And before go to communication, let's go to set the manual of our computer, right, IP address of our computer. Okay, here is the manual IP address of computer. Actually like this, if everyone not yet set the manual IP address, so we can right click and then open network and sharing center, and then go to local area connection, and then choose the property, and then go to IP4, yes, TCP IP4, and then choose 192.168.20.253, right, the same as my slide here, yes. And please tap, it will fill the subnet map for us, yeah, 255.255.255.0, yes, and then click OK and OK again and close, and then go to communication for CPU number 1, right? So go to double click on communications and then choose the Ethernet adapter, yes, and wait a moment for scan the CPU. Take time a little bit. So right now we found 3 CPU. The first one is 192.168.2.2. Second one 192.168.2.3, and the third one is 192.168.2 .20.1, right? So basically we can click on the IP address which one that we want to configure for PLC1, yes. Example, I would like to set this one for PLC1. I just click the plus line and then take a look to the PLC. It will blink the network, yes. So let me freeze the plus line and then let's see the status together. Okay, let's see. It blink, right? Okay, blink. Plus line, right? So this one is blink. Let's see. Yeah, this one. Blink, right? So this is a PLC one. Then we can stop plus line and then go to edit, right? So 192.168.20.1, yes. Then set. and then click OK. So we will got IP of PLC1. Yes. And then we can create the new project of PLC1. Example, I will create the push button stop. Example, stop M1, M0.0, stop M1, M0.1, start M1. And then I will control turn on the Q 0.1, sorry 0.0, and I will hold the signal by Q 0.0. Yes, and then we can compile. Okay, no error occur. And then we can save the CPU 1. Yes, let's check. Go to one HMI connect to 3 PLCs, right? So example, this one PLC 1 or CPU 1. Yes, and then we can download to CPU 1. If I download, the CPU 1 will stop, right? Let me show when we download. So right now the CPU is running. So when I press stop, let's see, the CPU 1 is stopped. And then download finish and press yes to run. Yeah, CPU 1 is run. And then we can online. We can go online. Yes. Okay. And for CPU 2 and CPU 3, we can follow the step. Yes. I will minimize this one first and then open for create the CPU 2. Okay, so first let's go to set up the CPU type, right? The CPU type is SR30, right? So let's go to choose the CPU SR30. Yes, SR30, and then go to start up and then choose the run mode also. Yes, and then press OK. And let's go to tick the communication and then choose the correct network adapter, and it will pop up the IP address of the PLC. Yes. Okay. So to make sure which one the PLC2 that we would like to set, we can press another IP address, and then we can press plus line, right? So let me press plus line. Okay, let's press the plus line. Let's see, the CPU middle is blink, right? It means that the CPU2 that we would like to set the IP address 192.168.20.2, right? Okay, so we can go to edit. So this one .20.2, right? Preset. Okay, finish. And then we can create the logic. Yes, example M0.0, M0.1, yes, M0.1, Q0.0, and I will hold the signal by Q0.0, right? Okay, and then we can compile. Okay, no error occur, right? And can save the CPU too. Yes. Okay. The CPU too, and then we can download. When we download, the CPU too will stop also, right? So let me show the condition when we download. So when we download, please yes, it will stop the CPU too. Yes. And then finish, click jack again to start the CPU too. Yes. And then we can close, and then we can online. Yes. So we can minimize for CPU 2. Yes. And go to step 7, microwin smart again for CPU 3. So first let's go to set the CPU type, right? The CPU type is SR20 also. Yes. So let's go to setup and then choose the CPU SR20 and go to start up, and I will run the CPU when power on. Yes. And then go to communication tab and choose the correct network adapter, and it will detect the 3 CPU also, right? And then we can press plus line, yes, to check to make sure the CPU is correct, right? So this one I will press plus line. Okay, let's press plus line and let's see the condition together. Okay, let's see, blink 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 when I press plus line. Yes. So we can set the IP address follow the slide 192.168.20.3, right? So let's go to set and then .20.3, right? Okay, .20.3 preset, and then click OK, and we will create the sample project, right, for CPU 3 Q0.0 also, right? Q0.0, and then I will hold the signal by Q0.0. Okay, and then compile the program. Okay, no error occur, and then I can save with the CPU 3, right? Okay, and then we can download. Yeah, please button download, and then the CPU will stop also, right? When we download, I will stop the CPU. Let's see the status. When press stop, the CPU will stop, right? And then download. After finish, click yes again to start up the CPU. Yes. So right now all CPU is running, and then we can go online. Go online, yes. So I will put like this. This one for CPU 1. This one for CPU 2, and this one for CPU 3, right? Okay, I will put like this. So this one we can put like this. Okay, and this one we can put like this. So we need to control all this data from the HMI, right? Actually, we can force the signal to see the status. Example, CPU 1, we can write, and let's see the output is turned on, and actual PLC is turned on also, right? Okay, I will write to off and then turn off. Yes. And then write to off again. Yes. So we can create the project from the HMI to control this 3 PLC. So let's go to WinCC Flexible Smart. Yes. Actually, we can simulation and download the project to the real HMI. Yes, I will show. The first one, I will show how to simulation, and the second one, we will download the project from this WinCC Flexible version 3 to the HMI. Okay. So let's create a new project, and I will choose Smart 700 IEV3, the same as my HMI hardware. Yes, so I will choose this one. Yes. So this is very important. If everyone have any HMI, we can choose the correct HMI. Otherwise, we cannot download from the project of WinCC Smart to the HMI. Okay, so let's choose the correct HMI, the same as our hardware. So click OK. And the first step, we need to create the 3 connection, right, of PLC 1, PLC 2, and PLC 3, right? So let's go to create the connection. Double click here. Example CPU 1. Yes. And I will connect to schematic S7-200 Smart, right? So choose 200 Smart. And I will choose the Ethernet port. Yeah. And here is my IP address of computer. So 192.168.20.253, right? This one. Yes, this one. And I will connect to PLC 1. So PLC 1 IP address is 192.168.20.1, right? And the next step, we will create the IP address or device for PLC 2. So I will choose CPU 2 and connect to schematic S7-200 Smart also. And the IP address of my PC is the same, but this one I will change to 2. Yes, the same as our slide. Yes, PLC 2 is .2, right? .20.2. And for PLC 3, CPU 3, I will connect to schematic S7-200 Smart also. And this one I will change to 3. Yes. So connection for CPU 1 is .1, CPU 2 is .2, and CPU 3 is .3. Okay. And for my PC is .253. Yes. So right now we already create the connection of 3 PLC. Yes, the same as this one. So we can command like HMI connect to PLC 1, and this one HMI connect to PLC 2, sorry, and this one we can mark as HMI connect to PLC 3. Yes, like this. for easy to understand. So the next step we will create the text. So let's go to this tab for create the text. So one CPU we have 3 texts, right? The first one is stop, the second one is start, and the third one is output, right? So we will create one by one. So example, this one we can choose the text. Example, stop PLC1 stop M1, yes, and choose the correct CPU. This step is already create the CPU, right? So we must select to be correct the CPU. Otherwise, when we control, it will wrong direction. Example, we would like to control to the CPU 1, but we choose the CPU 2 connection, it will wrong. Okay, so let's choose the CPU 1. And for data type, I will use Boolean and start from M0.0, right, for stuff here. Sorry, stuff. This one CPU 3, but the same, right? Okay, for CPU 1, M0.0 is stop, M0.1 is start, and Q0.0 is output, right? So I will choose M0.0. This one we can go to create for start M1, right? Okay, and M0.1 start M1. And for the output we can use PLC1 underscore M1, yes, and then I will choose the Q0.0, right? It is the output. So we can create more for CPU2, right? So example, PLC2 stop M1, and this one I will choose the CPU2, right, here, because we will control the stop button to the CPU2, yes, and the address will start from M0.0 also, right? Okay, CPU2 here, M0.0, M0.1, Q0.0, okay, and this one we can start M1, right? The CPU2, right, the same as the take number 1, and then M0.0, sorry, M0.1, and for PLC2 M1, right, CPU2 connection is CPU2 Boolean, and I will start from Q0.0, okay. And for PLC3 we can also PLC3 stop M1 and choose the CPU3, and the address will start from M0.0, yes, this one, CPU3 M0.0, M0.1, and Q0.0, okay. So PLC3 start M1 Boolean also, and start from Q0.0, right? Okay, so take for M1 CPU1, M2 CPU2. Oh, this one, sorry, it will start from M0.1, right? And one more, PLC3 M1, right? Boolean also, and CPU3 connection, and it will start from Q0.0. Okay, so right now for take PLC 1 we already created, PLC 2 we also created, and PLC 3 we also created, right? So let's go to our screen. I would like to separate 3 screens. The screen number 1 for PLC 1, and I will create one more screen for PLC 2, and we can rename this one example main page. Yes, I will rename as main page. Property example main screen. Yes, and this one I will use for PLC 1 screen, and I will create more for PLC 2 screen, and one more for PLC 3 screen. Yes, so I have main screen here, I have PLC 1 screen, PLC 2 screen, and PLC 3 screen, right? So I will call the main button. So main button we can go to create a button for call the screen 1, screen 2, and screen 3. So I will put this one first and then choose the text. I will write the text. Okay, welcome to PLC and HMI training. I can choose the font size to be 20, yes, like this, and I will change the background to be okay, maybe yellow color is okay. Okay, yellow color, and I will change this one to be example 28. Is okay or not? 28. Okay, it's still okay. So we can simulation to check the screen is okay or not. Okay, that's okay, but I will change to be center and middle, right? I will go center and middle. Okay, like this. Maybe I change the background to another color. Example, this color. Okay, okay, this color. And then I will change this one to be 30, sorry, and then let's simulation again to check the screen. Okay, ตอนนี้ okay, right? And then we can put the button for call the screen, right? Example, I will call the screen, go to property, and this one example PLC 1 screen. Okay, call the PLC 1 screen, and then I will adjust the font to be 16. Yes, and this one I will put PLC2 screen. Yes, PLC2 screen, and this one PLC3 screen. Okay, so we have 3 buttons for call the screen, right? So when we push this one, we will got the screen number 1 PLC, and when we push this one, we will got the PLC2 screen. Push this one, we will got the PLC3 screen, right? Okay. So to call the screen, we can go to property and then go to event, click, and then choose the activate screen. Yeah, this function, activate screen, and then we can choose the screen name, right? We can click here. So we can go to screen 1, PLC1 screen. Yes, and for this one we can activate screen also, and choose the screen name, screen 2, right? And for this one, activate screen, so screen number 3 here. And then for screen number 1, number 2, and number 3, we can copy this one. Yes, so copy and then go to PLC1 screen, and we can paste. Yeah, we will got like this. Go to, okay, I will change the background a little bit to be this color for screen number 2. Sorry, for screen number 1, and then we can copy this one to screen number 2, and then paste. Number 3, paste. Yeah. So we can go to screen number 1 and number 2. I will change the background to be this color. Yes, maybe this color is okay. And for screen number 3, I will change the background to be this color. Yes, and then we can save the project. Go to desktop and then go to choose the one HMI connect to PLC 3 PLC, right? So this one HMI project. Okay, so we can simulation for open and close the screen for test. So this one is main screen, right? So I will call the screen 1. Yes, call the screen 2, call the screen 3, call the screen 1, call the screen 2, call the screen 3, and we can also call main, right? So I will add more for main screen. So let's adjust button a little bit, and then I will copy one more for main screen. So this one we can write go to main screen, right? Or we can write only main screen. Okay, and then we can adjust a little bit more. Okay, so this one we can call the main screen, right? So I will go to event and then choose this one as main screen, and then we can copy to paste on screen number 2, and then we can adjust this screen. Okay, and then go to screen number 3, and then we can paste and adjust the screen also. Yes, and then we can save and simulation the screen again. So right now I will switch to screen number 3 and then go to main screen, screen number 2, main screen, screen number 1, main screen, and also go to screen, another screen we can select, right? And here maybe I can put the text. Okay, we can copy. So this one example main screen. Okay, main screen, I will go to the font size, adjust to 24, sorry, maybe 48. Yes, main screen 48, and then we can copy and then go to PLC 1 screen. So this one should be I will change color to be this color, and then change the text as PLC 1 screen. Yes, and then we can go to copy and then paste here. So this one should be PLC 2 screen, and then copy and then paste here, should be PLC 3 screen. Yes, and then we can save, and we will create the button for start and stop and status the motor of each screen, right? So let's go to screen number 1 first, and then choose the button. Yes, example, choose the button for start. We can write as start motor 1. Yes, I will change the color to green color, sorry, change the color to be green or a blue color. Yes, blue color, and I will adjust the size to be 16. Yes, so this one start motor 1, and we can copy for stop motor 1 and adjust the text. So this one should be stop motor 1, and I will change the color to be red. Yes, red color, and then we can go to choose the motor, right? So let's go to choose the motor here. Yes, go to VinCC Principal and go to this tab and choose the symbol factory graphic and go to another tab that we want. Example, I go to this tab and then find the tab of motor, right? Okay, motor here, and then we can choose another style that we want. Example, for motor number 1, I will choose this style. Yes, drag and drop. Okay, we will go like this. Okay, and we can adjust the size that we want. Yeah, for this style, everyone can design another style that we can look with the beautiful screen. Yes, so we can adjust to be aligned. Yes, okay, and then save the project. And we need to configure the button, right? So this one, start. Okay, for button start, let's go to event and then go to press. So when we press, it will set the bit, right? So I will choose set bit and choose the bit PLC1 start, right? Okay, start. And then when I release the mouse or release the key on the HMI, I will reset the bit, right? I will reset the PLC1 take start also, right? And for the button stuff, we can follow this step also. Active, set bit. So set bit PLC1 stuff. And when I release, I will reset the PLC1 stop, right? PLC1 stuff. Okay. And for the status of the motors, we can choose another color that we want. I will go to the object and then choose like this. Normally I will change this one to red, and when the motor is running I will change to green, right? So I will choose take PLC1 M1, right? And then when it on, it means that it turn on or it running. I will change color to be green. Okay, save the project, and we can simulation for test for PLC1. Yes, okay, so PLC1, this one, right? So let's go to screen 1. Yes, we will go like this, and then we can start. Okay, when start, let's see the output is turned on. Yes, and then the motor will change to green also, right? And when I press stop, it will stop. Start again, it will start again. Stop, it will stop. Okay, so we can copy to another screen. Yeah, screen 2 and screen 3. So I will select all and then right click, copy, and then right click and paste here. We just change the text for event, right? Go to event, please. Just change this one to PLC2. Yes. And then this one also change to PLC2. And for stop, we can change to PLC2 also. And release, change to PLC2. And for the status, we can change to PLC2 also, right? PLC2 M1 status. We can simulation, yeah, to check. Okay, I will minimize, and then this one for PLC1, PLC2, right? So let's go to PLC2 and start. Okay, turn on, stop, start again. Yes, so that's correct. And then we can copy to PLC3 screen also, right? So I will select, then right click, copy, and then go to screen 3, right click, paste. Yes, and then we just change this one to be PLC3, right? This one also change to PLC 3. Yes. So it's very easy to control. Yes. This one change to PLC 3. And this one change to PLC 3. Yes. So the last one change the PLC 3. Yes. And then save the project so we can control to all screen. Yes. So first let's go to screen number 3, yeah, to confirm this one working or not. So let's click start. Yes, when I start, let's see it turn on. The motor is running because output is turned on. Stop, start again, stop, start again. Yes, so it worked perfectly. Yes, this one start. Yes, it worked perfectly between 3 screen. And for the main screen, we need to show the status of the motor also, right? So example, we can copy, or we can show only the status of the motor run or stop, right? So basically we can use copy, yeah, copy this one for motor 1, right? Copy to screen 1, yeah, this one for motor 1. I will adjust to small a bit. Yes. So we can copy to motor 2 and copy to motor 3. Yes. Like this. Okay. And we can put the name, example motor 1. Okay. And this one for motor 2. Copy. And this one for motor 3. Yes. And I just change this one to be PLC 2, right? And this one to PLC 3. Okay. And I will change the background to be like this, maybe easy to understand. Maybe like this. Oh, cannot see, right? I will change color to be another color. Maybe change to yellow. Yes. For main screen, I will change to green. Okay. I will choose bold. And we can adjust. Yes. Okay. And I will adjust the size to be 36. Yes. Because it's just the motor name. Yeah. Motor 1, motor 2, and motor 3, right? And then save the project. And we can simulation again. Okay. Oh, this one is not okay, right? So we can adjust to be like this. Yes. And this one like this. And then simulation again. So we mask simulation before we download to the HMI. Otherwise, like this. Let's see. Here is hidden, right? Because it look like a big size, right? So I will go to 29 and then adjust and then simulation again. Try to simulation before download to the real HMI, right? So let's see, right now the motor 1, motor 2 and motor 3 is running. Yes. So if we would like to stop, we can switch to screen mode and then stop and go to main screen. Let's see, the motor 1 is stop. Stop. Okay, I will stop. And let's see, the motor 2 is stop also. And I will stop this one also for motor 3. Yes, it shows stop. Okay. So if we would like to set the analog, yeah, example, we can set the analog also. Let's go to test. For digital, we already tested, right? For PLC 1, example start, PLC 2, example start, PLC 3, example start, and main screen also show the status of the motors 3, 2, and 1 is running. So right now we will go to create more for analog set point, right? Yes. Okay. So first let's go to PLC 1 because we need to set the value to the PLC also, right? Yeah, if we have the project. Example, set point the speed of the motor, set point the frequency of the VFD. Yes. So we need to put the analog value. Okay. So basically we can use like this. Example, we can use SM0.0 all the way on. And then I will use add real. Example, add real. So I will add VW, sorry, VD 10 and VD 20. Yes, and then the result is VD 30. Yes, like this. And then we can compile the program. Okay, no error. And then save. And then we can download to the PLC 1. Stop the CPU again. Click yes to run the CPU back. And then we can online. Yes. So 0 plus 0 equals 0, right? Example 0, I will 10 plus 10 plus 0 equal 10, right? Example 10 plus 12 equal 22, right? So we need to set the VD10 and VD20 from the HMI of PLC 1, right? Okay, so we can test. So first we need to create the text, right, for PLC 1. Example real one, PLC 1 real one. Yes. And I will choose the real and VD, right? VD 10, PLC 1 real 2, right? VD 20, right? So VD 20, because our program is VD 20 also, right? This one. And the result is VD 30. So PLC 1 real Q VD 30. Yes. And then let's go to screen 1. And then we can choose the I/O, right? This one. So example, I will use this format. Like this. Yes. And then let's go to the text. And this one for input and output. This one for input. So the input number 1, I will use input for set the data. Yes. And let's choose the text. Sorry, PLC 1, real one, right? And the format, maybe I choose this format. Yes. And then we can design. I will choose the green for text, and background I will choose red, and this one I will choose this one. Font size I will increase to be 22. Yes. And for the text format, let's go to text format. I will choose center and then middle. Yes. So this one for in one, right? Input 1. So we can copy from this one and then choose in 1. Yes, input 1, and then adjust the size to be like this, and change the color. I will change yellow color. And for input number 2, we can copy. Yes. For input number 2. And then I will change this one for input number 2. And the format is the same, right? We just change to real 2. Yes. And one more is the result, right? So result in 1 minus in 2. Sorry, in 1 plus in 2, right? So in 1, example in 1 plus in 2. Yes. In 1 plus in 2. Equal output, right? Maybe I will adjust this motor to like this. Okay. Then this is the result, right? So we can copy and then change the format to be output only, right? So this one, output only. Yes. So if we save the project and then simulation, we will got the result, right? Because we already forced the signal. Yes. Screen 1. So this one example I set 40. Oh, I will remove all 4 first. I will unforce first. Unforce all, right? And then we can set example this 120. equal 20, right? Incorrect. So I will change this one to be real 3. Yes. PLC 1 real 3, right? And then we can simulation again. Okay, right now 0. Maybe we can use the function like this. Can read also, so we can choose this one. Yes. Okay. Then we can simulation again. So I will test with 40H. Oh, not come right. VD10. Let me check the CPU. Maybe incorrect the text, right? Oh, this one CPU 3 incorrect. So we can choose CPU 1 first. So it is very important. If we select the wrong CPU, it means that the wrong connection also, right? So be careful for this step. And then we can simulation again. Okay. And then go to PLC 1 and this one maybe it's okay. I will change to 40. Yes, 40 equal 52, right? And this one I will change to 20. Yeah, the result is 60, right? Example I will change to 90. Yeah, 110, right? Okay, so it worked perfectly. And then for PLC 2, PLC 3, we can create the program the same as PLC 1. Okay, let's go to PLC 2 first, offline, and then we can use SM0.0, it means that always on, and I will add real VD10, VD20, VD30, yes, and then compile the program, yes, no error, and then we download to the PLC, and then run the PLC back, and we will go like this, and we can go to PLC 3, yes, also go offline, and then go to add the always on, yeah, SM0.0. I will choose add real, so VD10, VD20, VD30, yes, and then compile the program, no error, save the project, and then download to the PLC and stop the CPU, yes, and then we can online also. So PLC 3, PLC 1, and PLC 2, we already created the sample for add the value, right? So it worked perfectly. Okay, I will zoom a little bit like this. Okay, and one more for this one. Yes. So PLC 1, PLC 2, PLC 3 is already created the add block. And then let's go to create the HMI. Yes. So first let's go to text, and then this one actually we can copy and paste and just change this one to real one. of PLC2 and choose this one. Yes, don't forget choose this one, this connection. And for this one is real 2 PLC2 and choose CPU2, and this one PLC2 also, and choose the CPU2, and we can copy and paste here. This one should be real one of CPU 3, and don't forget change this one to 3, real 2 of PLC 3, change this one to CPU 3, and output for PLC 3, choose the PLC 3, yes, CPU 3, and then go to the screen. So the first one is already created, right? So we can copy. I will align a little bit and then copy. Yes. Control C. Paste. Yeah. And I will adjust this button and motors a little bit like this. Okay. For this one, we just change to PLC2. Yes. Change to PLC2 because the text is the same. This one change to PLC2, and we can save and then simulation again. Okay, so this one is a PLC2 program, so we can test screen number 2. I will change to 1 2 3. Yes, let's see 1 2 3 1 4 5. Yeah, 1 4 5, and this is the result 2 6 8, right? That's correct. And then we can go to screen number 3. I will copy this one also. Yes, copy, and then go to screen number 3, and I will adjust this one to be like this, and then I will paste. Yes, like this. Maybe I will change this one to be black color, and for this one I will just change only PLC3. This one PLC3 also, and this one is PLC3 also. Yes, and then we can simulation and test. After that we can download this screen to the real HMI. Yes, I will show step by step about how to download to the screen, and then we can control together. So this one for screen number 2, I will start the motor first and go to screen number 3. Screen number 3, this one, right? PLC 3. So I will set point to be 589. Yes, let's see, 589. This one 789. Let's see, 789. Okay, so it worked perfectly. Yes, screen 1, screen 2, and main screen. So we need to download this HMI project to the real HMI, right? And then test together. So before go to set the HMI, I would like to show the screen a little bit. Yes, don't forget this IP address of the HMI. So 192.168.20.4. Yes. So let's go to set the IP address of the HMI before we download the project of WinCC to the HMI. So let's go. Okay, this is HMI. So when start up, let's go to bridge. Okay, when it start up first, let's go to control panel and then go to transfer. Make sure we put this one like this and then go to OK, and we need to go to Ethernet, yeah, and set the IP address. It's very important for IP address, otherwise we cannot download if we put the wrong IP address and we cannot connect from our PC, right? So for this one is 192.168.20.4, right? So I will set 192.168.2.20, right? Change to .20 and .4. Yes. And then please OK. Yes, OK one more time. And recheck again to make sure the IP address that we put is keep here. Click OK. Yes. And then we can please transfer. Yes. And then let's go to our project of WinCC. Yes. So first we will close the simulation first. And then go to our project. Yes. Go to the main screen. Okay. And then we can ping the IP address. Sorry. Ping 192.168.20.4, right? So it show like this. It means that we cannot communication with the HMI. Okay. So let me check the LAN cable. Yes. Of HMI connect to the switch properly or not. So wait a moment. We can type like this: ARP A ARP D 192.1 192.168.20.4, and then we try to ping again. Cannot ping, right? So let me check the LAN cable. Okay, right now I connect the LAN cable to the HMI, and then let's see here is can communication between HMI and our PC, right? So let's go to download. So we will put the IP address of HMI here, 192.168.20.4, right? And then please download. Let me show when it download the project. It will show the step also. Yeah. So let's click here. Yes, and then click here. It will transfer. Yes, finish. Okay, right now finish download to the real HMI, and then we can also simulation. Yes, so we can see the status. I will zoom for PLC2 like this. And then put the HMI here. Yes. And let's test the real HMI together. Yes. So let's see here the HMI. We already downloaded the program from the schematic VCC flexible, right? So we can go to screen number 1. Yes, we will see like this. And then we can stop. We can start. Let's see the PLC is turned on and off also when we push stop, start. And for screen number 2, let's go to screen number 2. Yeah, please screen number 2. And then we can stop. Okay. Let's see the condition of PLC. Start, stop, start. And then let's go to screen number 3. Yes. Screen number 3, we can push stop, push start. Yes. And we can test for set point also. Yeah, example, I will change this one to 5. Yeah, it will calculate to this step. Yes. So it works perfectly between 3 PLC and only 1 HMI, right? So go to main screen like this. Yes. So this is just example about how to connect and control the PLC only 1 HMI to 3 PLC, right? So I hope everyone will follow my video step by step, because I already go slowly, yeah, too easy to understand. So thank you very much for watching my video. And if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to say I'm sorry if I have mistake in this video. And I would like to request all of you to like, share, and subscribe my video also, to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to link the HMI Schneider model GHO certified 02 with PLC S7-200 Smart CPU SR30. Before go to create the new program for test, I would like to explain the diagram a little bit. Okay, right now I will use software Step 7 Microwin Smart and Wikido Designer version 6.2 service page H. To create the new project, to download to the HMI by using the USB Type B, and I will connect the connector RF485 from PLC S7-200 Smart to HMI port COM2, and the transmission is 9600 for this communication. And I will use LAN cable, create project from the step 7 microwin smart, and then download to the PLC smart by using the Profinet port. Okay, so this is the sample example that we can create the start and stop button and the signal of the output here, and then we can pre-start and stop from the HMI. Okay, so let's go to our software to create a new project for step 7 microwin smart and VGO designer version 6.2 to download to HMI and PLC and then test together. So let's go. Okay, so first let's open the step 7 microwin smart. Right now I will use version 2.5. Yes, basically we can create the start and stop button for start and turn on the output. Yes, so let's go. First I will create the button stop, example M0.0. it is the button stop. Yes, we can write as stop BP. Yes, stop push button, and I will use start button M0.1, and we can define the symbol start PB. Yes, and I will turn on the output for schematic S7-200 Smart CPU SR30. There are digital output 8 and plus 4, right? So 12 output. Yes, so I will turn on 12 output, so we can use the Q0.1, sorry, Q0.0. it is the output 0, and we can copy 1 2 3 4 5 6 7 8. Yes, and then we can connect the wire. Yes, and I will hold signal if I push the button start. So I will hold Q0.0 output 1. Yes, so let's change this one to 1, this one to 2, this one to 3, this one to 4, this one to 5, this one to 6, this one to 7. So 0 to 7, it is 8 bits, and then I will create one more button. Yes, we can compile, and then this network I will create one more button, example stop PB2. This one I will rename as stop PB. Example this one I will create M0.2, it is stop PB, stop PB2, and one more button M0.3, stop PB2, sorry, start PB2, and then I will turn on more output. Yes, here 1 2 3 4. Yes, so it will start from Q1.0. So I will use coil, and then Q1.0, Q1.1, 1.2, and 1.3. It is the last one, right? So I will change this one to 9, change this one to 10, and change this one to 11. Yes, the last one. And I will hold the signal. When I turn on output number 8, yes, and then we can compile the program. Yes, no error occur. And then we will download this program to the PLC. So first let's setting the CPU. Okay, SR30, and then for startup I will start run the CPU. Okay, and then let's check the communication between our PC and PLC. So let's go to communication and then find the CPU. Okay, 192.168.20.2. Then we can ping. So ping 192.168.20.2. Yes, that's okay. It means that we can connect and communication between our PC to the PLC. Yes, and then we can download. Stop the CPU, and then I will run the CPU back, and we can online. Yes. So if I push start, this output will on, and I push stop, this output will off. Okay. So we will go to create the project of VGO Designer to download to the HMI Slider. Yes. So let's open VGO Designer and then create the new project. Example PLC S7-200 Smart. Yes, and then click next to continue. And for target name, I will choose S7-200 Smart. Yes, and here is the model that we already installed here. Yes, so if we install the VGO Designer, we will got this model. So right now let's choose the model to correct with the hardware, and right now I will use HMI HGO series, and HGO series there are 3 types that we can use. Has HMI HGO 0, HGO 3501, 3502, 5502. Yes, so right now I will use 3502. It is the same as my HMI. It means that here, yes, GHO 3502. Okay, and then click next, and then click next. And here is very important that we must add the driver to the HMI, driver the PLC, yes, otherwise it not work. So let's add the driver. So there are many type of PLC model. Example: ABB automation, immersion process management, generate driver, Mitsubishi, Omron Corporation, Rockwell Automation, Schneider Electric, yes, industrial, Schneider Electric USB accessory, Siemens AG, Toyota Machine Work. Okay, so right now I will use Siemens AG because I connect to the PLC S7-200 Siemens, yes, and then I will choose the Simatic S7 MPI/PPI, and then choose the S7-200 series, yes, so click OK. So it's very important, if we choose the incorrect type, it will not work perfectly, yes, so let's choose the correct type and then click finish. It will got the screen, yeah, provide the screen default, and for the screen we can change the color, example this color, or we can change another color that we want, yes, so I will choose the color. And we need to create the push button start and stop, right, for turn on the output. So example, I will choose the push button here, yes. Okay, example, stop PB1, yeah, and here we can choose the font size, yes, example I choose this one, yes, it will got like this. If we choose this size, yes, okay, and if we would like to change the color, we can go to the color and then choose here. Example, I will change to red color, yes, it will go like this. If we would like to change the text color to be black, can also change like this. Okay, and then we can copy for button start PB1. And then we can rename to be start PB1. Maybe we can change the size a little bit because it's so big. So let's go to label and then choose design, yes. This one we can also change the style. Go to label and then choose design, yes. Okay, and then we can align because we need to put the button, yeah, so we keep the space for another button for group 2. For start button, I will change to blue color. Okay, and we can design the style that we want. Yeah, it pre-style for designer. Okay, and then I can copy for button for group 2. So I will rename this one to be PB2, and this one also PB2. Okay, and then we need to declare the parameter of the button, right? Yes, because if we not define or declare the function, it will error. Yes, compile not successful. Yes, because the function is not defined. Yes, so we can configure. Example, stop push button 1. Let's see here, it is M0.0, right? M0.1 it is start, M0.0 it is stop. So we can go to push button, and then here we can use bit because we use bit, and here we can choose set reset toggle. Set it means that set forever, reset it means that reset the function, toggle it means that when we push one it will hold, we push again it will release, and for momentary on it means that when we push it will on a little bit, and then when we release it will off. And for momentary off, if we push it will release off. Okay, so right now I will use momentary on. If I push one part it will release. Yes, and then let's go to choose the tag. Yeah, I will choose new tag. Example, stuff PB1, and the data type is boolean, and then it is the scan group. It means that we connect to device of PLC S7-200 smart. For device address we can choose here and choose %M. So for stop M0.0, right? So it correct. Okay, like this. And for start is the same function. We can go to source and then choose bit, and I will use the momentary on also because I need, if I turn on push it will turn on, if I release it will turn off. And then go to destination and create the new tag. Example, start PB1, and I will connect to the PLC S7-200 smart. So I will choose device and then M0.1, right? M0.1 it is start, and then click OK. OK one more time, and OK one more time, and OK one more time. Okay. So we need to configure the group 2 also, right? For group 2, yeah, push button stop group 2 M0.2. Yes, so double click and then go to operation bit, momentary on, destination, I will create new text, example stuff PB2, and it will start from M0.2, right? Okay, one more time. And for start, it will start from M0.3. So bit M0.3 momentary on, and then new text, example start PB2, and address is M0.3. Yes. Okay, one more time, and then okay, one more time. Okay. And we need to show the status of the digital output also, right? Here. Example, we will show this status. Yes. So it will start from Q0.0 until Q0.7, right? So I will choose the text. Example, connect PLC S7-200 Smart with HMI GHO 0 3502, right? Okay, and then font size, we can use the font size. It will come like this, or we can use another size. Example, I will choose bold. It will bigger than before. And if we choose another size like this, it will big. Yes, and we can adjust. Okay, like this. And we need to show the status of the output, right? So let's check, use the lamp. Yes, example lamp 0. Yes, for lamp 0, let's go to the variables here. So for general, we can use the variable here, and for the color, we can use another color that we want. Yeah. Example of color, I will use red color, and on status, I will use green color, and for the type, I will use this one. Yes, 02. And for the variable, we can go to create a new example Q0. Yeah, and it will start from Q0.0. Yes, okay, like this. And then we can copy for bit number 2, bit number 1, bit number 2, bit number 3, bit number 4, bit number 5, bit number 6, and bit number 7. And one more for group 2, it is 4 bits more also, so we can copy. Yes, so we can align like this. Okay, and for this one, we can align also. Yes. and then we will configure for bit number 2 here. Example, I will use new and then Q2, sorry, Q1. So Q0.1, this one I will define the new Q3, sorry, Q2, Q0.2, and for the color I will choose the same, yes, the same format with the first. So this one should be Q3, so Q0.3, and this one should be Q4, so Q0.4, and this one Q5, so Q5, and then Q0.5, and this one for Q6, so new Q6, Q0.6, and the last one for group 1, it is Q7, so Q0.7. Okay, and then for group 2, I will start from Q1.0, right? So let's go to color and then choose. This one should be Q8, right? So Q8. And start from Q1.0, yes. Q9. So it will start from Q1.1, Q10, it will start from Q1.2, right? And the last one should be Q10. So Q10. Sorry, this one should be Q11. And then start from Q1.3, right? Okay, so 1.0, 1.1, 1.2, and 1.3. Okay, so totally 12, yes, 12 bits. And then we can simulation before download the project to the HMI, yes. Or we can adjust the size, maybe bigger than this. Okay, like this. we can adjust the size. Okay, we can adjust one by one. Yes, so we can design the style that we want. If everyone would like to design another style, yes, we can design. So I just example, so I will use this style first, and then for this one I will adjust also like this. Yes, adjust like this. Okay, like this. And the last one. Okay, and then we can save and then simulation again. Okay, good. So we can download the project to the HMI. So before download, let's connect the USB Type B to the HMI and PC. Yeah, let me connect. And then I will choose the VMware. Yeah, because right now I use virtual machine. Okay. And we can check the connector if we properly install. We can check here. Yes, we can take out the USB Type B and then insert again. Yeah, and we can check here. Yeah, it is the driver of HMI that we can download. HBTZ935/USB-B. Okay, it means that USB Type B. So we can go to download here and tick here and then click yes to confirm download. And wait a moment for downloading. Okay, right now it's downloading. Yes. Okay, it download finished, but it doesn't configure the baud rate, right? So we need to create the baud rate. Yeah, configure the baud rate for COM2. For PLC S7-200, we will use 9600, right? Yes, it's very important. If we choose another baud rate, transmission rate, we cannot communication between HMI and PLC, right? So let's click here 9600 and then download again. Okay, waiting for download again. It will reboot the HMI a little bit during downloading. So don't turn off the power of HMI during downloading, otherwise it will error the HMI. Yes, so be careful. Right now it complete downloading. Yes, and we can take out the USB Type B from computer. Yes. So right now we can test together. I will push start. Let's see. The output is turned on for 8 bits for group 1, and for group 2 we can push start. Yes, but the color is incorrect, right? For this one, maybe we can change the address. Yeah, so let me change the address. Bit number 2 of group 1 and number 3, right? So this one should be, oh, this one should be Q10, right? Should be Q10, right? Okay, so choose Q10. And this one should be Q11. This one is Q0. I will revise the address again. This one Q0, this one Q1. This one should be Q2. This one should be Q3. This one should be Q4. This one should be Q5. This one should be Q6. And this one should be Q7. And for group 2, this one should be QH. Okay, it's correct. This one should be Q9. This one should be Q10. And the last one should be Q11. Yes, correct. And then we can save the project again and then download to the HMI again. So I will connect the USB type B again. Okay, when we connect the USB type B, it will ask again. And then I will choose Visual Machine. Yes. And make sure we go to check the device manager here. Yeah, this one. It means that we already connected the USB type B cable. So we can download. Yes, download again. Okay, downloading. So wait for downloading. Don't touch anything with the HMI. It will reboot automatically by itself. Yes. So take time a little bit for downloading. Okay, so right now it finished and then we can online here. So let's see Q 0.0 until Q 0.7 is turned on, and Q 1.0 until 1.2 1.3 is turned off. So we can push the button. Yes, tap with me together. Okay, so let's test again. I will start the group 2. Yes, it turned on. Stop the group 1 again. Turn off. So the color is correct. Turn on again. Turn off this one. Turn off this one. Start group 2. Start group 1. Yes. So it worked perfectly between HMI Schneider and PLC S7-200 Smart. Yes. So this is just an example about how to link the data from PLC S7-200 Smart to Schneider HMI by using the COM2, yes, and baud rate 9600. Okay. So in this point, it's very important. If we choose incorrect baud rate, it doesn't work perfectly. Yes. So we must choose the baud rate 9600. Okay. So thank you very much for watching my video. If everyone have any question, please kindly drop comment. under my video. I will reply soon. And I would like to say I'm sorry if I have mistake in this video. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. And I will drop the example project under my video so everyone can download to learn or to use. So for this time, I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about new topic about how to wiring the proximity sensor to PLC S7-300 CPU 314C 2PN/DP. Okay. So before go to create the new program for test to see the actual signal of proximity sensor, I would like to explain the concept and how to wiring clearly. Okay. Before we test, we need to know about how to wiring clearly about how to connect the proximity sensor to the PLC. Okay. There are two proximity sensor right now I will use, and I will use two control relays. The first one is NPN proximity sensor, and the second one is PNP proximity sensor. And we will use the semantic manager and VinSys flexible to create the sample program for test and easy to understand. Okay. So let's go to the drawing detail about how to wiring the proximity sensor NPN and PNP. Okay. So let's go with me. Here is the drawing that I already draw for everyone for easy to understand. The first one I have CPU 314C 2PN/DP of PLC S7-300, and if we purchase the CPU 314C 2PN/DP, we will got the built-in I/O for the analog and digital. Okay, and then we can use analog tie and digital tie. There are analog input, analog output, digital input, and digital output. Okay, and here is the memory slot. Here is the switch, run, stop. Yes, and here is the Profinet port, and here is the Profibus port, and here is the terminal power connection that we can connect 24 voltage to this terminal to supply the CPU. Okay, and in this section I have two proximity sensor. The first one is NPN tie and the second one is PNP tie. Okay, so this is a difference between how to wiring the proximity sensor NPN and PNP. Okay, so to wiring or connect the proximity sensor to the PLC, normally we use relay control, yes, one more relay control, or we can also connect to directly. But for the safety, we can use the relay control, and then we can take the NO or NC contact to the digital input of PLC. Okay. So if we would like to wiring NP and tie, we can connect the positive power 24 voltage to the cable of proximity sensor. Yeah. Normally, when we order the proximity sensor, we have the catalog, so we can follow the catalog. Normally, the positive power, we can use the ground cable, ground color, and we can connect directly to the relay, magnetic relays, and then one more cable, we can connect the minus 24 voltage or 0 voltage to the blue, yes, and then black cable, it will generate to the relay. So when we detect the object here, the relay is turned on, and then we can take the NO contact to the digital input, yes, and then it will turn on when we detect this object. Okay. And also P tie, we can connect the positive cable to the brown. Yeah, this is a brown cable. I forgot to remark. And then this is a blue cable. Blue cable we can connect with M. Yeah, M it means that 0 volt or minus 24 volt to the proximity, and then it will generate the black cable to the relay K2. And when we connect the object here, when we touch or connect the object here, it will turn on the relay, and relay will generate the contact to the PLC. Okay. So the first cable is brown, the second cable is black, and the third cable is blue. Okay. So we can follow my drawing, and then we can test. Okay. And for the terminal 20, terminal 40, we can connect together, and then connect to terminal 30 of digital input. This is common. So we can connect 0 volt DC to here. And then for the terminal number 1, terminal number 21 and 31, we can connect the plus. It means that 24 voltage to this terminal, and then we can test the proximity sensor. Okay. So I hope this drawing is clearly for everyone about how to connect the proximity sensor, tie NPN, and one more time for PNP to the PLC. Okay. So next step, we will create the new program for test and then simulation with the HMI for see the real actual of the signal of proximity sensor. Okay. Because right now I already connected the cable from my proximity sensor to the PLC. Yes. By through the relay also. Okay. So this one and this one is the same. I already connected the cable. Yes. So next step, let's go to create the new program for test together. Yes, let's go. Okay, so first let's go open Semantic Manager. Okay. And we will create a new project. I will create a new folder. Before create the new project, yes, I will create with the S7-300 proximity with proximity sensors. Okay, and then let's go to create the new project. Yes, new example test proximity. Yes, and then browse to find the folder that we already created on desktop here, and then click OK. And next step, we will create the new objects. Semantic 300. Example, this one we can rename as proximity sensor. Yes. So go to hardware configuration and then go to Semantic 300. Go to the rack. Yeah, the first one we need to create the rack. And then we can create the CPU. Yeah, insert the CPU. I will use CPU 314C 2PN/DP. And here is the IP address of the CPU. Yes. Okay. So when we choose the CPU type 314C 2PN/DP, we will got the digital input, analog input and output, counter, position control. Yes, counter, it means that encoder we can read also. Yes, so good. And I will save the project. Okay, and then we will download the hardware configuration to the CPU, right? So before download the hardware configuration to the CPU, first let's go to put the IP address of our computer. Okay, right now I will put the IP address. Yeah, if everyone not yet put it, should be like this. Yeah, so we cannot ping to the CPU, right? Example, I will ping 192.168.0.1. Yeah, we cannot ping, right? So we need to insert or put the manual IP address of our computer. Right now I will put 192. So 192.168.0.253. Yes. And then we can test again. Yes. We can ping. It show like this. It means that we can communication between our computer with the PLC. And then we can download. During the download hardware configuration, the CPU will stop a little bit. Yeah. So if the machine or the motor still running, then we download the hardware configuration, it will stop. So in this step should be careful. Yes. So I will download the hardware configuration. Okay, from the CPU again. And then we can go to create the signal of proximity sensor, right? The input number 1 I will connect to the DI 136.0, and for the proximity sensor number 2 I will connect to DI 136.1. okay, so let's go. So let's go to OB1. I will choose the ladder for language. Okay, so we can see the signal from the proximity sensor. So we can comment as read the signal from proximity sensor 1. Okay, so the first one here I connect to input number 1. Yes, so input number 1, if we look like here, yes, 136.0, right? So I will choose NO. So I 136.0. Yes, and then we can edit the symbol. So proximity sensor 1. Okay, and I will turn on the output if we touch or we take the object to the proximity sensor here. Yes, when we take the object to this sensor, it will turn on the output. Okay, so we can write as Q 136.0 also, right? So I will create one output, and then it will Q 136.0, and this one we can edit the symbol, rename as output of proximity sensor 1. Yes, like this. And for proximity sensor number 2, I will connect to relay number 2 and then connect to the input number 2 and turn on the output number 2 also. Yes, so this one I will create one more network, and then we can copy from here and change this one to 2, and for the input here we can use I 136.1, right? And this one should be proximity sensor 2. Yes, and I will turn on the output number 2, so Q136.1, and then we can edit the symbol. So for this one we can type output of proximity sensor 2. Yes, and then we can download the logic to the PLC. For download the logic, we no need to stop the CPU, right? And then we can online for test. Okay, so right now I will go to the proximity, yes, and then test. Okay, right now we will test one by one for proximity sensor. So I will type the proximity sensor number 1. Yes, let's see. Number 1 is turned on, and then the PLC is turned on, and the signal is turned on also for output. Yes, and then if I put the object to the proximity sensor number 2, yes, it will turn on, and the stator of PLC is turned on also. Yes, relay is turned on. If we put 2, yeah, proximity, it will turn on 2, yeah. So it works perfectly. Yes. So it very easy to wiring the connection of proximity sensor type NPN or PNP. Yes. So we can follow my drawing that I already show on the slide. Yes. Then it's very important if we control the motor or some the process, we can use the proximity sensor instead the limit switch. Yeah. The concept is the same, limit switch. If have the object, then it will cut the signal. Yeah. Then we can take the signal from the PLC to control the process. Okay. And then we can create the sample HMI for test this signal also. Yes, with the simulation. So let's go to create the sample project. So first let's go to open the WinCC flexible. And then go to create the empty project. I will use the HMI MP277 10-inch touch. And then first let's go to create the connection. Example HMI 1 proximity, and then the driver we can select the PLC S7-300 400. Yes. And then I will choose Ethernet, and here is the IP address of my PC. So 192.168.0.253. Okay, and for the PLC is 192.168.0.1. Yes. Then this one we can comment as connect HMI with PLC S7-300 proximity sensor. Okay, and then go to create the text, right? So the first one is signal from the proximity sensor. So I want 36.0. So this one example input proxy 1, and then it is the boolean, right? So I will choose boolean and start from I. So I 136.0. Yes. For a command, we can command as input of proximity sensor 1. Yes. And then it will generate the output, right? So Q 136.0. Okay, so this one should be output proxy 1. So boolean, and then I will choose Q 136.0, and this one is output of proximity sensor 1, right? And for the proximity sensor number 2, we can copy and paste, and this one should be 2, and this one should be dot 1, this one should be 2, and this one should be 2, this one should be dot 1, right? And this one should be 2. Okay, and then we can go to create the screen to show the signal of proximity sensor. I will choose this color. Yes, and then we can create. Okay, I will put the text for the title, example test pro. Okay, test proximity sensor with PLC S7-300. Okay, then we can increase the size, and I will choose the yellow color. Go to property and then change the yellow color. Okay, and we need to show the signal of proximity sensor, right? So let's go to the rectangle example. This is the signal of proximity sensor. Yes, number 1. I will put here. And then I will change this color to red color. Okay, normally red color, when the signal is on, it will change to green. And for the output, I will put like this. Okay, this one I change to red color also. Yes, and then I will copy to proximity sensor number 2. Yes, so this one is input and this one is output. so I can copy the text with input. Yes, and this is the output. Okay, output. Then I can align to be top. This one should be top also, and this one should be like this. Yes, this one also should be like this. Yes, and then for this one is proximity sensor, so example sensor 1. This one for sensor 2. Yes, so for this one okay, so we can put the sensor 1, sensor 2. Yes, go to animation and choose the text. This one should be proxy input proxy 1, right? So choose input proxy 1, and then I will change the color when it true. Yes, I will change to green. And for this one also input proxy sensor number 2, I will change to 1 and then change to green color also. Okay, and for this one should be out put proxy number 1, I will change to 1 and then change the color to green. Okay, this one should be out put proxy number 2, and this one change to 1 and change the color to green. Yes, and then we can test. Can save the project first. Yes, this one example proxy VT sensor. Yes, and then we can simulation. Yes, simulation with the PLC, and then we can test again. Right now the PLC is online. Yes, so I will type the object on the proximity sensor again, and then let's see the status together. Yes, because we already configure the signal of proximity sensor. Yes, okay, so right now I will type the proximity sensor number 1 again. Yes, let's see the signal on HMI is green. Yes, I will type with the proximity sensor number 2. Yes, it's green. Number 1 is green. When I type number 1 and number 2, yes, let's see green together. Yes, so it works perfectly for the configuration of HMI. Yes, so this is just concept about how to wiring and how to connect the cable to the PLC S7-300 by using the proximity sensor and relay control. Okay, so I hope this video just the basic for wiring and create the small project on the schematic manager and Vinci placeable for test. Next time I will create the one project that related to the proximity sensor. To example, start the motor belt conveyor, and then we can use the proximity sensor to install on the pulley of the belt, and then when we start the motor and then the belt is not rotate, and then the sensor is send the signal to trip the motor. Okay, so in this video I just show like this first, yeah, and then we will go to part 2 together. So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to link data between PLC S7-300 to HMI Schneider GHO certified 02 via RS485 cable. And in this section I will use two softwares together. The first one is TIA Portal version 16, and the second one is Video Designer for create the new project of HMI and then download to HMI by using the USB type B. We can download from our PC to the HMI. Okay, and I will use TIA Portal version 16 to create the sample program on the PC and then download to the PLC by using the PLC S7-300 CPU 314C 2PN/DP. Okay, and I will use LAN cable connect from Profinet port of PLC to my LAN card of my PC. Yes, and in this section I will detail how to use the software Video Designer version 2.6 with page 8, and we will create the sample screen and then test with the PLC. Okay, so let's go to our software. Okay, first one I will use TIA Portal version 16. So let's go to open TIA Portal. Yes, wait a moment for open the software, and then we will create the project together. After that we will download to the PLC. Okay, so first let's go to create the new project. Example link S7, link HMI 1. Yes, and I will go to save the project file, I will go to desktop and then create the new folder. Example HMI Schneider. Okay, and then click create to create the project, and wait a moment for create the project. It takes time a bit to create the project. Yes, so let's go to project overview. Yes, and then go to create new device. Okay, so right click and then create new device, or double click to add new device. So I will use the schematic S7-300. Yes, let's go to choose the CPU. Right now I use CPU 314C 2PN/DP. Yes, version 3.3, and then click OK. It will create the project for us. Yes. Okay, so when we use the CPU 314C 2PN/DP, we will got the internal I/O. Yes, internal digital and analog input and output. Yes, here. Yes, we will got analog output and input card, digital input and output card. Yes, here. And we will see the I/O address, right? But first, let's go to see the I/O address. Right click and then property. So the input address will start from this is a analog, yes, analog address, and this is a digital address. Yes, digital input, it will start from %I 136.0 until %I 138.7, totally 32 bits. And for the output, it will start from %Q 136.0 until 137.7, totally 16 bits. Okay, sorry, okay, 16 bit. Yes, and we will use this output to show the signal on the HMI, yeah, when we push any button. So we can download the hardware configuration to the PLC first. Yeah, so go to right click and then go to compile first. Yeah, to check the program. Yes, hardware configuration has error or not. So we must compile the program before download to the PLC. Okay, and then we can download the hardware configuration to the PLC first before we create the logic for test. Yes. Okay, so I will search the device because I already connected the LAN cable from my PC to the Profinet part of PLC S7-300. Okay, so right now it detects one CPU 314C 2PN/DP, and here is the IP address of the PLC. So we can load the hardware configuration. And then we can stop the CPU, yeah, during we download the hardware configuration, the CPU will stop. Yes, so stop the CPU, and when finished we can start the CPU. The CPU will start. Yes, okay. And right now the hardware configuration is already downloaded from our PC, yes, to PLC. So let's go to create the sample logic for test with the HMI. So let's go to program blocks and then go to OB1. Okay, so we can command on the network, example create push button control from HMI Schneider. Yes, so here we can use NC, yes, NO, white, and we can hold the signal. Yes, basically we can learn from the basic like this before go to advanced. Yes, so here I can use example M0.0, example stop command. Yes, stop CMD. And here example M0.1 start command. So start CMD. And here we will use the output, right? So to see the status we use output. Yes, and output it will start from Q136.0 right here. So we can use the Q136.0 example output 1. Yes, output 1. And then we can hold the signal, so Q136.0 also. Okay, and then we can save the project and then compile. Okay, compile successfully, no error occur. And then we can download the logic to the PLC. Yes, okay. Basically we no need to stop, but in this time I stop the CPU again. And then start the CPU back when we finish. Okay, and then we can online. Okay, right now we already complete the logic for test the sample program. So let's go to create the project of HMI. Yes, so I will use another window to create the project of Video Designer to download to the HMI Schneider. So first let's go to open the Video Designer. And then let's create the new project. Yes, and we will create the project name, example link to TIA click next, and then here example PLC S7-300, and we need to choose the model of HMI. Yes, in this type there are many types that we can use, but I will use HMI GHO series because it matches with my HMI. Yes, and then this is the series of my HMI, so GHO 3502. Yes, it's very important in this step. If we select the incorrect type of HMI, we cannot download to the HMI. Okay, so be careful in this step. Choose the correct type of HMI and model, and then click next. Click next again, and here also very important, we can add the devices. So right now I will use Siemens AG. There are many driver that we can use. Example ABB automation manufacturer, immersion process management manufacturer, Brown Corporation, Rockwell Automation. Okay, right now I will use Siemens because we connect to the PLC S7-300, and I will choose the S7-300-400 series. Yes, and then click OK and finish to create the project. So we will got the sample screen. Yeah, in this screen we can change the color background and other color that we like. Yes, example I change to this color. Yes, and here we can use the text. Example welcome to PLC S7-300 and TIA Portal tutorial. Okay, and for the font size we can change here. Yeah, example I will change to the size design. Yes, so we can change, and then we can adjust the area. Yes, that we want. Okay, example we can change like this. Yes, and for the text color we can change the text type that we want, the text color that we want. Yes, so we can change like this. And for the push button, yes, push button start and stop from the HMI. Yeah, we will use this address. So start is M0.1, stop M0.0, and for the output is U136.0. Okay, so we can use example. We can go to create the variables. So go to variables tab. Here double click the variable. So here we can use boolean. Example I will insert the boolean, and we can create as stuff. Okay, data type is boolean, and I will use external. Yes, and here is the driver. Yes, and here is the address that we use. So M0.0, right? It is stop button, and we have many functions. Example, if we would like to lock to group 1, we can lock. Yes, So I will create one more boolean. Yes, example start. It is the boolean also, and we use external because we link from the PLC. And here is the address. So M0.1 it is start. Yes. And one more, it will show the status, right? So I will choose boolean one more. Example output 1. Yes. It is the eternal, and it will start from Q136.0, right? Okay, 136.0. So we can type 136 and then choose 0. It means that 136.0. Okay. So right now we already created the variables. So let's go to screen and then choose the button here. Okay, I will choose the stop button. Okay, and here we can choose the source, and here we can use bit, right? Because we use boolean, and we use momentary on. Yes, and here we can choose the variable that we already created. So I will choose stop. Yes, and I will choose the format 002. Yes, and here is the color. So we have many color that we can use. Example for the button, we can use the color on and off. Yes. So here we can OK first, and we can go to double click and then go to color, and here is the switch one, right? Switch one, it means that stop button. So we can go here, frame color, and for the label, yeah, for the label we can choose another label. Example stop. Yes, and for the font size we can choose this size. Yes, and it will become like this. So for the color, text color, I will change to red. Yes, sorry, change to black color. Yes, and for the push button, I will change to blue color. Yes, like this. Okay. And for the start button, we can copy, yes, and then rename here. We just choose start, right? And for the color, I will change to be blue, and change this one to red because it is the stop button. Yes, I will change to red color, and this one blue color. Okay, and this one I will rename to start, and the font size is the same. So right now we have start and stop. One. And then we can choose the lamp for show the signal of the output, right? Example lamp 1. Okay, I will choose this one. So we will use the color animation, right? So it is the output one. Yes. And the color I will change. When off, I will show the red color, and when on, I will show the green color. Yes. And for the label, we can use also example when the stator on. Example, we will show running. Yes. Running. Yes. Label running. Okay. So on this color and off this color. Label is running. Yes. Or we can use bold. If we would like to change the size, we can also choose this size. Yes. It will come like this if we change the size of the button, of the lamp. And we can change another color that we want. Yes, here. So I will choose like this first, and then we can go to the configuration before download to the HMI. Yes. So the first we can go to config the baud rate. Yes, it's very important. If we choose another baud rate, example 9600 or 19200, we cannot communication between PLC S7-300 and this HMI, right? So we will choose 187500. Yes, and choose the COM port 2 RS485. Yes, and for another parameter we can use default. Yes, and we can go to the project and then go to option, general. So this is a download option. If we choose the file system, we can download to the USB, and then we can store the data to the HMI. Yes. So right now I will choose USB first, because I download directly from my PC to the HMI. Yes. And here is the option. If we choose the include edit the project, next time we can upload the program, upload the file from the HMI to use. But when we uncheck like this, we cannot upload the project file from the HMI. Okay. So I will include the editor project. Yes. And then we can save the project. And then download to the HMI. Yes, I will download to the HMI. Before download, we can simulation to see the status of HMI first. So when we download finish, it will come like this. Yes. so we can download. During download, be careful, don't turn off the HMI. Yes, turn off the power of HMI, otherwise it will error. Yes, the runtime error. So right now, downloading. Okay, right now we already downloaded the project to the HMI, and then we will go to see the status of the PLC. Yes, and let's test together. So right now the PLC is online. Yes, so let's test the push button. Okay, right now I will push the start. Yeah, let's see the output is turned on. Yes, and the color is show also. Yes, and if I push stop, yes, the output of PLC is turned off, and then color change to red color. Yes, so it means that communication between PLC and HMI is working. Yes. So next step we will create, if we would like to set point the value from the HMI, yeah, we can also do it. And then first let's go to create the data block. Yes, so right click and then create the block. Yeah, create the new block, and I will choose the data block. Yes, and then choose the automatic to add the block. Yes, we will add like this. Example, we would like to calculate the value. Example, value 1. It is the real. Example, I will choose real for data type. And then set point, can set point also enable. And example, value 2. I can set point also. It is real. Value 3. I'm no need to set point because it is the output. So if we would like to use the value 1 plus value 2 equal value 3, yes, we can also do it. So I will compile first. Okay, so it will start from db1 dot dbd0 dot dbd4 dot dbd8, right? Okay, so let's go back to our ob1. So here example, add value 1 and value 2. equal value 3. Okay, so we can use add, yes, enter, and then I will add real, right? So I will choose real, yes, and here is the data block value that we already created, right? So I will use data block 1 value 1 right here, and for this one I will use data block 1 value 2, yes, and here is the result, right? So result we can use data block 1 value 3, yes, and then we can save the project, compile. Okay, successfully, no error occur, and then we can download to device also, because we just create the data block 1, yes, and then we can online, yes. Okay, so we will got db1.dbd0, db1.dbd4, and the result is db1.dbdh, yes. So let's go to our HMI program. Okay, so I will adjust this one to be like this. Yes, maybe I will change the color of the text to be black, yes, like this. We can design the style that we want, yeah. It is just example for communication, so everyone will design the same style or another style that you want, yes. So I will use value, yes, so value is numeric display here, so I will use value 1, yes. We can also create the value variable from here, yes. Example, I will create the plotting, yes, and here is the display digit that we will put. Example, I will put 6 digit, and for the decimal place I will put 2, yes, and here is the enable input, so we can set point, yes, and it will come like this 1 2 3 4 5 6.12. It is the format, yes, and for the font size we can use another size that we want. Example, I will use this size. If we would like to use bold, we can use like this, so it will come like this. It's so big, right? Okay, we can use like this, and we would like to design another style that we want, so we can use like this and go to the color. Yeah, we can choose text color. Example, I will change to green. Frame color, yeah, frame, it means that here I will use white, and for the plate color I will use black, yes, it will come like this. Input type we already enable mode, right? Because we need to set point, yes, so that's good. And for the variable, we can go to create the new variable from here also. So create the new example value 1, and I will choose real for data type. Yes. And here is the device. It means that we connect to PLC S7-300, and here is the data type address that we choose. So I will choose db1.dbd0. Yeah, it is the address of this one. Yeah, db1.dbd0. So db1.dbd0. Okay, then click OK, OK again, and OK again. Yes. And for the value 2 and value 3, we can also copy from here. Yes. So I will right click, copy, right click, and paste. Yes. And this one I will create the new variable. Yes. And for the format, I will keep the same as the value 1. Yes. So let me create the new variables. Example value 2. In here we can also create another variable that easy to remember. Yes. So I will use db1.dbd4, right? Value 2. And then click OK. OK again. And this one will change to value 2. Yeah. This one value 1. And this one value 2. But the format I will keep the same. Yes. And we also keep the input mode, right? Enable, because we need to set point also. Right? And we need to put the result, right? So result no need to input. Yeah, I will uncheck this box. And for the variable, we can create the new variable. Example value 3. And the address will start from db1.dbdh. Yes, this one. Yes, db1.dbdh. Yes, so db1.dbdh. It is value 3. Yes, that's okay. So for text, I will use plus. Yeah. And then I will use the font size like this. And then we can adjust. So this one plus this one. And then equal this one, right? So if we know the basic create, we can also create the project for our machine. Yes. So basic is very important. Yes. So please follow me step by step. Okay. So this one plus this one equal this one. Yes. And then we can save the project and make the simulation to see the status before we download to the HMI. Yes. So that's good. And then let's download to the HMI again. Okay, click yes to confirm download. Yes. Take time a little bit during download this project to the HMI. Yes. And be careful. Don't close or don't turn off the power of HMI. Otherwise, the runtime will be error. or damage the software of HMI. Yes, so be careful when we download. Don't touch anything such as power and another screen of HMI. Yes. Okay, so right now we already downloaded the project to the HMI, and then we can go to see our PLC. Yes, so right now 0 plus 0 equals 0, right? So let's test together. Okay, 0 plus 0 equals 0. Example, I put this 1 so it equals 1, and the PLC is 1 also. Example, I put 123.123. It will equal 123.12. Yes, because we put the decimal place only 2, and this one, example, I plus 44 125.25. It will show like this. Yes, so that's good, working properly. Yes. So this is just basic about how to set point and show the result on the HMI. Yes. And I have one point that need to show to everyone also, because we need to use also. Yes. Example, we would like to set the timer, delay timer on or off, or timer path from the HMI. We can also create, right? Okay, so example, set timer value from HMI. Yes. So basically I will create the timer on. Yes. So I will use timer on. Yes. And this is a timer on. Yes. So default I will use like this. So if we would like to control the output delay on, we can also set from the HMI, right? So basically we can set point the HMI by using like this. Okay, I will show this step first, and then after that we will convert this one to another step. Okay, so db2 IEC db2 dot pt, right? And this one IEC2 dot et, right? Okay, and then I will use M0.2 for enable the timer. Example, I will use M0.2, and this one example enable timer. Yes, and then I will control the output. Example, I will turn on the output Q136.1, right? Because it is continue from the Q136.0. Yes, so this one we can rename as output 2. Yes, and if we would like to turn on another output, we can also parallel with output. Example Q136.2, it is output 3. Yes, yes, and then we can also turn on another output. I will turn on file output, yeah, for example. So Q136.3, and this one should be output 4. So output 4, and this one Q136.4, it is output 5. Yes, and this one Q136.5, it is output 6. We comment like this for easy to understand our program. If we have any project, we can comment like this. Yes. So if I enable the timer and the setting, yes, the timer equal setting, it will turn on this output, right? Okay. So we can test like this first. So we can save the project and then compile the program. So error 1, yes, IEC count which one? It's not possible in target, right? DB2. Let's compile again. Timer, this one. It is timer on, right? Okay. DB2, right? Okay. So it's error 1, yes, because we write the logic is incorrect. Normally the output we cannot parallelize this with the timer, yes. So if we would like to turn on another output, we can use like this. So I will copy this Q. (136.1) to here, and then I will cut this network and then paste here. Yes, and then try to compile again. We will got no error, right? So we cannot parallel with the interrupt this one. Yes. So we can save the project and then download to the PLC. Yes. Finish, and then we can download all to PLC. and then start the PLC again, and then we can online here. Okay, so if we enable the timer, and then we can set the value of timer PT here by follow db2.dbd2. It will turn on the output, and then the output here it will turn on another output. Okay, so to create the HMI, we need to use the db2.dbd2, and to show the status of timing, we can use db2.dbdh. Okay, so let's go. So I will add more, yeah, the screen, right? So we can copy from here. So this one, it should be set the timer, right? So I will create the text. Set time. We can use bold, and for the text we can use another color. Example, I will use yellow color, and for font size we can use this size. So we have set timer, and we have show timer, right? So I will adjust here, copy one more. This one should be show, or we can write timer status. Okay, time show. We have time set and time show, right? And then we have the enable button, right? So I will put like this. Okay, it is the millisecond. If we write like this, it will come to a millisecond. The unit is millisecond, right? So I will change the color to be white, and this one is millisecond also. Yes, and we need to create new variable, right? And for the address is db2.dbd2, and the time show db2.dbdh, right? So let's double click. We need to enable the input, right, for this one, and I will create the new. I will use integer and create the new. Actually we can create the variable from here. Yes, example, set timer, and it will start from db2 dot dbd2, right? So db2 dot 2, yes, db2 dot dbw2, right? It is the double integer. Yes, I will choose double integer. Yes, timer set, and I will show the only sec. Yes, 6 digit, or we can use 8 digit. Yeah, because it is millisec, right? Okay, and for this one we no need to enable the input because we just show the signal. Yes, so I will put 0, and this one put h also, an integer, and I will create the new. So example time show, it is double integer also. Yes, and for the address is db2 dot dbdwh, right? This one. Yes, db2 dot dbwh. Yes, okay, it will come like this. And we have the push button, right? Or toggle the input for timer here. So we need to enable. So I will copy this button. Yes, copy and paste, and we can write enable timer. I will adjust the size a little bit to be like this. Yes, and I will change the color to be, maybe I will use this color. Yes, enable timer, and we need to create the variable also, right? So the address is start from m0.2, right? And output q136.1. So m0.2, I will create the new variable, and I will choose toggle because we need to one click and then enable the timer. Yes. So I will create a new variable, example enable timer, and address is start from m0.2. Yes, so m0.2 here. Okay, and then click OK. And we need to show the status of the output also, right? So we can copy from here. Actually, we can also draw, yeah, the new one from here. Example, I will show 5 output, right? So one output, it is the bit. Sorry, we will choose the lamp. Yes, so I will choose like this, and for the style I will use this style or this style. Yes, example, this one output 2, because output 1 we already use, right? So output 2, I will create the new example output 2, and the device is start from Q136.1, right? So address will start from 136.1, right? Okay. Yes, it will come to output 2, and I will use this style. And for color, when off, I will show red color, and when output on, I will show blue color, green color. Yes, and then click OK. Okay. And if we would like to use the text, example show on or off, we can also use the text. Okay. This color on or off, right? Okay, we can use the text. Can use like this, yeah. And we can enable, yes, the option here. Example value, position, color. So right now we would like to show the value, right? So I will enable the value, yes. Boolean, yes. So when on, I will show on, and when off, I will show off. And the text, I will use the output, this one, right? Yes. So when output on, it will show on. When output off, it will show off. Okay. And for the size, we can also adjust the size. Yes. Okay. Can use like this. And for the color, I will use the black color. Yes. And then we can copy to another for lamp. Because we have a total 5 lamp, right? For when the timer is reaching, and then the lamp is turned on, right? So we can adjust to be 5 output. Okay. We can put like this first. It is just example, yes. So everyone can design the style. Because we will start from basic first, yeah. Okay, so I will adjust this slide, yeah, this take a little bit to be center with this output, because the purpose is turn on this output when the timer is racing, right? So for output number 2, okay, we will create the variable from here, yeah, easy to create. Example boolean. So this one output 3, and the address is Q136.2, right? Copy and paste. So output 4, this one should be .3, paste again. Output 5, .4, paste again. Output 6, .5, yes. So until .5 or .6, right? We can check again. So it will start from .2, .3, .4, .5, and .6. Yeah, totally fine, right? Okay, so we can go to our screen. Yes. So this one we can configure step by step. So this one should be output 3. Yes. And this one should be output 3 also. Then we can adjust. This one should be output 4. This one should be output 4. This one output 5. And for the lamp is output 5 also. This one output 6. And for the lamp is output 6 also. Yes. And we can save the project and we can simulation before download to see the status of screen. Yes. Okay. And then we can download the project to the HMI again. Yes, the project is starting downloaded. So wait a moment for downloading the project to the HMI. And next step I will show how to set the unit as second. Yes. Okay. We will go step by step. It's just the basic. Okay. So right now we finish download. But the font size is very big, right? So I will change the size should be smaller than this. Example like this. It detect, and then can you design, but we can use the option for ball. Yes, this one also. It's very big. Okay, we can change to ball. This one also change to ball, and this one also change to ball. Yes, and for this one we can also use the text, example running or stuff. Yeah, so this one output one, right? So we can copy the variable and then copy from here, output one, and for this one I will delete the label. So when we push the button on, it will show the running, right? So running, and this is stop. Yes, and then we can save the project and then simulation again. Okay, and then we can download the project to the HMI again, because we just revise some size of the lamp. Please okay, yes, to confirm. So wait a moment for download the project. Okay, download it now. Okay, finish. So we can go to our PLC, yeah, and test together. So I will zoom a little bit, zoom out, for easy to see the status. Yes, like this. So let's start together with me to test. So first we need to set the timer. Yes, so example I set 5000. It means that 5 seconds, right? Because the unit is millisecond. Yes, so if I turn on the enable the timer, it will count. After that output will turn on, right, and change the color, and this one is change to on also. Yes, so if I disable, it will off, and enable again, it will count again, and then turn on the output again. Okay, so actually we can also create the more logic for set the second. Yeah, I will show. So if we would like to set with the second from the HMI, yeah, unit each second, we can follow me like this. I will insert one more network. Yes. So this one I will use the multiply. I will use multiply and multiply double integer. Yes. So I will multiply this one by 1000 and then create the temporary variable. Yes. Example timer 1 mul. Yes. And the data type is time. The data type should be double integer, right? It's time. And then here I will use timer 1 mul. And then this one is timer 1 mul also. Yes. Actually, we can drag and drop this one also. Yeah. So I will multiply by 1000 and then here is output from multiply. And then for this one I will keep the same. Yes. So let's compile our program and then download to the CPU and we will go like this. Yes. So if I set 5 from the HMI, I will multiply by 1000 and it will go to set here 1000. It means that 5000 here. So 5000 equal 5 second. Yes. So we will go to revise our HMI. So this one should be second, right? So second. And for this one I will keep the same. And for this one I will divide by 1000. Yes, just put like this and then download to the HMI again. We will got second. Yes, set second from the HMI. Okay, wait a moment for download the project to the HMI again. After that, we will test together set by second and let's see the result together. We can also use apply the basic, yes, to be advanced if we have the basic. Yes. For me, I also start from the basic. Okay, so right now it already download. So let's go to our PLC, yeah, to see the status. So right now it 0, right? So let me set the timer. So if we set 5, it means that 5 seconds, right? Set 5, it means that 5 seconds. So multiply by this one is db2.dbd2, right? So we will keep this one the same as before. Okay, so let's test together. So if we try to set example 5, we cannot set, right? Yes, because we need to revise the logic. Yes. So I will create one more variable in the db1. Yes, before we can set. So I will create the set timer. Yes, and the data type is time. And we can compile. Or here we can use int, yes, the Boolean integer. And then go to ob1 again. And here we can instead by data block 1 set timer, yes, and then we can save the project and then compile and download to the CPU again. So this one okay, we can override. Okay, download finish, and we can online to check. Here become 0, right? And then we will go to revise the HMI. It will set by db1.dbd12. Yes. So db1.dbd12. I will change this one to be db1.dbd12. Yes. And we can recheck here. Set timer db1.dbd12. Okay, and then we can download to the HMI again. Yes, to confirm. So wait a moment for download the project to the HMI. and then we will test together. Take time a little bit for download. Okay, right now finish download, and then let's go to see the status here. So right now it shows 0. So let's try to set the timer. Example, I set 5. It will 5000, right? It means that 5 seconds. And let's start for test. It will count 1, 2, 3, 4, 5, and output is on. Yeah. If we would like to adjust to be 10, yes. And then try to start again. Enable. It will count 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Output is on. Okay. So normally we set as with the second. Yes. So this is just a sample about how to link the data or control the data from the HMI to the PLC by using the Schneider HMI and PLC S7-300. And for the software, we already use the TIA Portal version 16 and VGO Designer version 6.2 CV page H. Yes. I hope this video is just the basic for everyone. Yes. Before come to advanced. Yes. So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to say I'm sorry if I have mistake in this video. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye.